Dzień dobry Państwu, mam wielką przyjemność.
Good morning, ladies and gentlemen. It is my pleasure to welcome you to this conference, AV Poland 2021, Autonomous Future of the Automotive Industry. My name is Katarzyna Węsierska, and I will have the pleasure of accompanying you throughout today. And we are indeed going to have a very interesting day. The autonomous future is right there. The question is, how far is it? How remote is it? Today we're going to be talking about what we have to do in order for vehicles to be able to travel Polish and international roads, how long it will take us, and what kind of legislative changes we might expect in order for the event to come for the future to come true. AV 2021. So let us now take a look at what was going on during the previous edition of this conference. Now it's time to officially open the conference, AV 2021 conference, and this can only be done by Professor Ślęzak of the Institute of the Automotive Industry. Minister, ladies and gentlemen, conference participants, I am very, very glad to be able to welcome everybody to this conference organized at the Sofitel Hotel in Warsaw, the second AV Autonomous Future in the Autonomous Industry Conference in Poland. We are now well ahead in terms of the state-of-the-art technologies used in the automotive industry. In 2015, we had the first international conference at the Institute focusing on hydrogen and its use in transport. This was when we could actually test even true vehicles with fuel cells. Today, nobody is discussing or debating the use of hydrogen in Poland in the automotive industry. We also have plans in Poland. Now, today we are also celebrating the first conference of the AV focusing on the AV topic, and those we have just seen photographs and footage from that conference just a few minutes ago. Today we shall be focusing on the telematics of autonomous vehicles on Polish roads. Today we are organizing this conference in cooperation with the National Center for Research and Development. And this conference is organized under the auspices of the Ministry of Infrastructure. I am very happy to see that we have representatives of the infrastructure industry and we also have foreign guests from the Visegrad Group, from the Czech Republic, Slovakia and Hungary. I would like to welcome scientists specifically representing the Horizon 2020 program, as well as representatives of the community of industry and the automotive, including the automotive industry, representatives of the business industry, and the many journalists. Have a fruitful meeting. Thank you very much for your attention. Professor Marcin Ślęzak, the director of the Institute of Automotive Transport. Now a few words from the Minister of Infrastructure. Ladies and gentlemen, dear participants of the conference and remote viewers of the AV Poland conference, a very warm welcome to the second conference focusing on the automation in the road industry, organized by the Institute of Motor or Transport Industry. The Ministry has extended its patronage over this conference because we believe in the importance of this project. When, in September 2017, we met for the first time, the area of autonomous mobility was a novelty in Poland, triggering major interest. We were then thinking and wondering how to approach the topic in a comprehensive way in order to launch a discussion concerning the responsible introduction of such technologies, including jointly with experts and scientists. We decided to ask the question, what ought to be the Polish road to automation in road industry? And as a result of analyses, we concluded that fundamental challenges then faced by all of us include the lack of proper structures, but also the necessity for the development of a systemic approach to this amazingly important issue. This is why in the strategy of sustainable development in the motor industry until 2013, we adopted in 2019, we decided to make certain changes to the automotive industry. Two requirements also launched in the European Union. I would like to emphasize that our project has been made part of the 22 key projects implementing the EU strategy. This activity has been launched by the Warsaw University of Technology, the Institute of Automotive Industry, and the Ministry of Infrastructure. We are also continuing our project to improve the road infrastructure, and we are doing that via the National System of Traffic Management, which in the first stage covers 1,100 kilometers of highways and expressways in Poland, making it one of the largest in Europe. Ladies and gentlemen, I am deeply convinced that thanks to the successive development of the functionality of smart road systems, communicating with vehicles will become a fact and our reality. At this point in time, I would like to emphasize that one of the subject matters of the project is that of analyzing the safety of road transportation via systems of transport automation. This issue forms part of a number of initiatives we have already launched. We have, for example, been basing our activities to improve safety on the road on 3 pillars. Firstly, investment. Secondly, changes to legislation. Thirdly, education. Let me only mention that we intend to unify the allowable speed throughout developed or housing territories. We also intend to introduce rules and principles concerning the minimum distance between vehicles. We have introduced such legislative changes. The government has adopted its program for the years 2021-2024. Thanks to this program, throughout Poland, well-lit pedestrian crossings and bicycle trails have been established across Poland. We are also introducing and building properly safe bus bays, all to improve safety on Polish roads. We believe that all these tasks deserve priority also in the context of automation, which is why when introducing innovative solutions, we are placing our stakes only on reliable and mature technologies. It would be difficult to organize such endeavors without a proper technological background, which is why we have decided to establish the Center for Automated and Combined Vehicle Technologies. We are now launching the project as part of the Institute for Automotive Transportation, and I am deeply convinced that, assisted by our collaborators, this project will take off and will become a form of support for all we are doing at the Ministry in order to implement automation on Polish roads. Ladies and gentlemen, I hope you have a fruitful debate, interesting discussions, and many interesting meetings. Minister of Infrastructure Andrzej Adamczyk mentioned what we are just about to do, the official opening of the conference at the Institute of Motor Transportation. That is very important, but we would also want to emphasize that Mr. Andrzej Adamczyk and the Commission for Infrastructure of the Polish Sejm have extended patronage over this conference. We are working with the Polish Academy of Sciences and the Polish Sejm. We are working together with the Robotek Eye, whereas the Polish Drivers Radio and TVP Info are our media patrons. We are going to hear from Polish and international experts. We will be transported to the British Isles and Italy. Let me start with the first session. That is the AVPL Road session. We are going to shortly witness the opening of this AV Poland conference. Now we are going to hear from Adrian Mazur, the Director Department of the Transport Strategy at the Ministry of Infrastructure. He will discuss the strategic approach to transport automation. Good morning, ladies and gentlemen. I am very, very happy to be attending this conference. My name is Adrian Mazur. At the Ministry, I am responsible for the strategy of transportation. I will deliver this brief keynote speech to present you with the transport automation in terms of the strategic approach. We are also going to be discussing challenges that we shall be facing over the next years in order to promote reliable and proven technologies only. The automation of vehicular transport is nothing new. We are now presenting you with the three fundamental trends that are going to impact the automotive industry. The first issue goes hand in hand with the new Green Deal of the European Union, that is the radical reduction of CO2 emissions. Until 2050, the transportation industry should limit its emissions by 50 industry. Now, another very important issue is the progressive urbanization. By 2050, two-thirds of the entire population will reside in cities. which obviously has its consequences to urban mobility and options for the automation in the transportation industry. We should also emphasize the growing importance of data. We have been talking about the digitization of the transportation and services industries, whereas now we are digitizing and datifying, if you will, which definitely proves how important these issues are. Now, what can we do to improve the topic with automation? Now, with regard to CO2 emissions, according to Cambridge experts, the 50% of automated vehicles present on the road may actually contribute to CO2 emissions abatement. Now, we can obviously also imagine that such automated vehicles will be driving along privileged tracks, so-called bus lanes. Moreover, in terms of data, 180 million email messages are sent per second around the world. It is estimated that an hour of using automated vehicle on the road may generate up to 6 terabytes of data, which definitely proves the scale of the phenomenon and the importance we should attach to transport datafication. Experts from the Canadian Policy and Planning Institute have asked the question, how long will transformation take? How much time do we need in order for automated vehicles to make it to the market on a mass scale? We do know that a number of projects have been introduced across the European Union by our foreign partners, but how long will the process be? Our Canadian experts tell us that it's going to take us approximately 40 years. We have 3 guidelines and stages we ought to mention. Firstly, 2030. By that time, automated vehicles ought to be commonly available. From 2040, this market will be sufficiently mature in order to be used by practically everyone, and by 2060 such solutions will prevail. Why? Well, by 2050 cars available for sale will be autonomous, whereas by 2060 50% of all fleet cars will be autonomous. Now, is 40 years a long time? Yes, it's a long time, but I believe that shortly we are going to be participants in hybrid traffic. We will have to face the challenges of combined or hybrid transportation formats. Now, what kind of challenges can we expect over the next couple of years? Obviously, the simple question is how and when such technologies ought to be allowed for traffic. This is what the professor and the minister were talking about, which is why we intend to analyze all available solutions, testing them on the Polish market in terms of their response to challenges as well. We should definitely prepare scenarios for AV implementation in order not to be surprised by any challenge that might appear. For example, responsibility, liability. Who is going to be held liable for accidents on the road? Will that be the driver, the software manufacturer, or the manufacturer of the vehicle? Such are the questions that we are now asking. Challenges included hybrid traffic of conventional and autonomous vehicles coexisting. Probably some time will pass before we are passed or overtaken on the road by a driverless vehicle. But is that really the distant future? Well, several days ago, Bundestag had adopted a resolution allowing Category 5 vehicles will be allowable on the road. Category 5 vehicles are vehicles whose systems can be overruled by a computer system. Obviously, it will take a while before we pass all legislative solutions, but I believe that soon we will be able to encounter such vehicles as drivers.
So how will the autonomous vehicle behave when, for example, there's a 50 kilometer per hour speed limit, but other vehicles drive at a faster pace than allowed. So this is the sort of questions we're trying to find the answers to in our project. There's the Chinese model where they prefer to add another lane just for autonomous cars, or using these solutions in public transport, first and foremost, again, in a separate bus lane. And for example, several days ago, Cambridge started a shuttle bus, autonomous shuttle bus service. So this is the scale of autonomy, and it is a very wide scale and range of possibilities that gives us further boost to complete our project that we started back in 2018. Now, another challenge we have to tackle as the infrastructure owner is preparing the infrastructure to work with autonomous vehicles. As the minister mentioned, we are implementing the nationwide traffic management system with 1,100 kilometers of Polish roads being digitized and adapted to this new infrastructure. As part of the project, the S8 and A2 roads will have the so-called smart collaborating elements where the infrastructure collaborates with the vehicle to have full autonomous solutions. This is necessary, and these solutions will be gradually implemented in the infrastructure. What changed in recent years is moving away from the traditional smart transport system to autonomous mobility, which is a much broader idea, and it includes all the participants in the traffic, and it shows how the collaboration between vehicles and the infrastructure can be used. Or, for example, how information about a potential collision can be used before it happens. Now, another point I would like to draw your attention to is the issue of data. We are implementing the National Data Access Point. To start with, it's going to be about statistical data, but for autonomous mobility, we need a functionality that will make it possible to use and transmit traffic data in real time. And then we'll have the so-called Federation of Access Points in the EU, where they will have to exchange data amongst themselves and with the drivers or the cars to provide real-time traffic data. Since the beginning of the project, the number of interested parties grew by 130%, and this shows the scale and the potential of this project. Cybersecurity is absolutely paramount, especially for autonomous mobility. You may remember a situation from 2015 where the control over a vehicle was taken over remotely, which shows that data protection, anti-hacking protection and virus protection are of particular importance. A similar situation happened in an aircraft where someone used the onboard infotainment system to take control of the airplane, and these issues are the sort of thing that will impact the development of autonomous mobility in the coming years. Now, about the strategic framework on the EU and Polish levels. Quite recently, the so-called Sustainable Smart Mobility Strategy was published by the EU. Transportation as a service, digitization of data, and the introduction of automation and autonomy in vehicles are trends that have been noticed by the European Commission, and we now have to implement it by 2030 so that we will be able to see this automated mobility as part of the EU system. The TEN-T network should also be made ready by the same deadline to work hand in hand with autonomous vehicles, so that we can say in a few years that we've got a comprehensive ecosystem for those vehicles. Now, about Poland, back in 2019, we adopted a sustainable transport development strategy where digitization is treated as a key tool to improve and strengthen our transport system and traffic conditions, as you can see on the slide that we're showing at the moment. So this translates into the different types of interventions between different sectors and improves the streamlining of traffic streams in the transport system in Poland. The Polish Road to the Automation of Road Transport is the title of a project that's very important as part of this strategy. We have 22 strategic projects that the Minister mentioned, including road construction, railway construction, the CPK program and others. Another project we added, which is not very costly but is extremely important in view of the challenges coming up in the future, is called the Polish Road towards the Automation of Road Transport. We follow the principle of safety first, and we start with tried and tested technologies. And this is the sort of debate we've been having with the Road Transport Institute, Warsaw University of Technology, and others. And I would like to thank the representatives of these institutions very much for the know-how and expertise that helps us develop this project. And the number of analyses is very large, and at the end of the project there's a tangible effect, the Autonomous and Connected Vehicles Competency Center. And we can proceed further with next stages of this project as a result of that. Now, as you can see in this slide, this is not just about analytics and reports. It's also test drives on a closed racing circuit and also in the streets of Warsaw. And over the 2 days of our conference, we'll certainly give you details and the preliminary results of these tests. Now, the results are not that obvious. Let me just tell you that some of the systems that we tested operate in a way that may come as a surprise in terms of when and how soon they are activated when driving. So this is the sort of thing we have to test thoroughly so that the drivers can rest assured that these systems are helpful and ready. Now, we have 21 projects altogether, tests on a racing circuit, preparing a green paper of autonomous vehicles, developing the competence center that I mentioned before, and also developing a broad awareness-raising campaign to promote autonomous vehicles in Poland. And the benefits from introducing them are obvious. In 2018, the value of autonomous technology investment globally was $100 billion, which shows you the scale of the needs and the investment that is going to be necessary in the coming years. Now, about the Center of Competence, the professor will probably discuss it in depth later, but just in a nutshell, it should be a center of debate and competence about connected and autonomous vehicles. Now, this area has not been particularly well developed in Poland, and I'm talking about the testing area. This could be another area for the center to be active in. But as the minister said, in 2017, we diagnosed that what is missing for these services to be developed is the structures and the personnel. I hope that thanks to this collaboration, the latter problem will cease to exist, and that we will develop the human resources needed to effectively implement these solutions in Poland. Now, Canadian experts are forecasting that we need 40 years to have fully autonomous traffic. Now, this is the result of a competition by the Nowa Era publishing house, where primary school students were asked to write about how they perceive the future of traffic. And this is an example, a student called Natalia, grade 7, and she says, "It's Saturday, 22nd of April, 2121. I'm standing in front of a passenger car factory in Warsaw. This is the Polometer, an autonomous car, is going to be launched today. It can be used even by people without a driving license. It has state-of-the-art computer system, and the passengers, once they get in, can, with the press of a single button, enjoy the views outside or read their favorite book. Polometer reacts to their voice commands. Will it be a revolution on the car market? I'm sure that this intelligent car will be a best friend of every human." Zero-emission autonomous vehicles should be used as friends. We are a single ecosystem: the driver, the car, the driver support system. So it's an interesting point to see how a primary school child sees the future. Now, she mentioned 2121. I think this is too distant of a date. So hopefully, during the conversations today, we'll try to come up with an answer for Natalia not to have to wait that long. Maybe we'll be able to bring it down to the 40 years mentioned by the Canadian experts. Let me give you a vision of how this project is part of the new mobility transformation paradigm in Poland. When we started in 2017, we talked about connected vehicles rather than autonomous vehicles, but this has transformed in the course of the project. There was a debate in the European Commission in the meantime, and now we are talking about connected, automated mobility. And this is much more than just the vehicle. It's also the regulatory framework, the structural framework, and the coexistence, or indeed the symbiosis of all the traffic participants. And I hope that autonomous and connected vehicles will develop in this direction. Now, about traffic data. Finland is where mobility as a service concept came up. It treats data as an important fundamental branch of transport. Now, I hope that I've been able to present some of the trends and the challenges that we'll have to face in the coming years. I've also mentioned the strategic framework, and for more details of our take on autonomous mobility, stay with us for more presentations today and tomorrow. Thank you very much. Have a good conference in this hybrid, partly remote mode, but since we have vehicles that can be controlled remotely, then certainly a remote conference is also part of this trend. Thank you, and enjoy the conference.
Pan Adrian Mazur, dyrektor Departamentu Strategii.
Adrian Mazur from the Department of Infrastructure mentioned that according to Canadian experts, it'll take us about 40 years to have first autonomous cars in our streets. But by 2030, we will hopefully see some of this technology on the Polish roads. We are launching a new center for this today. Back in 2017, Andrzej Adamczyk, the Minister of Infrastructure, mentioned the need for a center like this. This will be a sort of a cornerstone or a foundation to develop innovative, automated solutions in Poland. So we are now witnessing the opening of the competence for connected and automated competencies. Mr. Ślęzak from the Road Transport Institute and the representative of the institute will now open it officially.
Szanowni
Ladies and gentlemen, we have now heard a statement by the minister from 2017, and today these words are becoming true. We are opening the Competence Center for Autonomous and Connected Vehicles as part of the ITS, the Institute for Road Transport. And this is a natural follow-up for our cooperation with Warsaw University of Technology and other bodies, and it's also a commitment we have taken on as part of the Polish Automation Road Program. The expertise of this unit lies mostly in the experience and knowledge of the staff. These are people who have participated in the work of expert groups for many years, and they have been supporting the government, including the transport, and I should say infrastructure ministry, from different platforms such as CCCAM, FORM-ITF, the Standardization Committee for ISO, and a number of other committees. In addition to the human capital, the R&D expertise is also a foundation. The ITS is a leading scientific organization in terms of road transport. It has gained its experiences over many years by implementing a number of projects, including a group of projects that pertained to the development of road innovation. The iDrive project, which was about simulation and the evaluation of road safety support systems. We've also developed innovative methods of training professional drivers using modern technologies such as virtual reality, for example, and for the so-called least favored groups. We also have the AVPL road program and the Trustonomy project, as part of which we are developing acceptance and trust in the mobility of the future, autonomous mobility. And we also deal with driver training. Our overarching objective is to support the Ministry of Infrastructure in a safe transposition of the EU acquis into Poland, also developing support systems for drivers and different R&D areas. The Competence Center will include 3 testing phases, and this is virtual tests, special tests on testing circuits, and finally real traffic tests. And you will see some videos about it in a moment. So let's have a look at how the Center of Competence for Connected and Autonomous Vehicles will work.
Dynamicznie rozwijające się technologie transportowe oraz postępujący proces automatyzacji przemysłowej to tylko niektóre z czynników, które wpłynęły na rozpoczęcie projektu o pojazdach autonomicznych przez Ministerstwo Infrastruktury. Wspólnie z Instytutem Transportu Samochodowego oraz Politechniką Warszawską zawiązaliśmy konsorcjum projektowe, a dzięki środkom z Narodowego Centrum Badań i Rozwoju w ramach programu Gospostratek możliwe było uruchomienie naszej aktywności w ramach tego przedsięwzięcia.
System akwizycji reakcji systemów pojazdu. Najważniejszą cechą systemu jest możliwość synchronizacji danych pochodzących z czujników przyspieszeń, czujników lokalizacji, kamer i mikrofonów. System umożliwia rejestrację takich parametrów jazdy jak odstęp podążania i czas do kolizji. W ramach projektu AVPL Road przeprowadzono badania w ruchu rzeczywistym, które odbywały się na trasie S8 w okolicach Warszawy. Ich głównym celem było zdobycie nowej wiedzy na temat wpływu systemów automatyzujących prowadzenie pojazdu na bezpieczeństwo ruchu drogowego. W badaniach wzięło udział 41 kierowców w wieku od 30 do 70 lat. Testy obejmowały jazdę z wykorzystaniem aktywnego tempomatu, asystenta utrzymania pasa ruchu oraz systemu monitorowania martwego pola pojazdu. Oprócz zbieranych przez system miar obiektywnych reakcji, badane były również odczucia kierowców. Całość uzyskanych danych pomiarowych posłużyła do sformułowania wniosków w zakresie interakcji kierowców z systemami automatyzacji jazdy.
Instytut Transportu Samochodowego dysponuje profesjonalnym zestawem makiet umożliwiającym badanie zaawansowanych systemów wsparcia kierowcy. Składa się on ze statycznej oraz pneumatycznej makiety wraz z systemem holowniczym. Każda z makiet pojazdu przedstawia tył typowego pojazdu osobowego i jest zgodna ze standardem AEB Protocol. Makiety wyposażone są w specjalne elementy oraz powłoki umożliwiające ich rozpoznanie przez systemy stosowane w obecnych pojazdach. Dodatkowo Instytut Transportu Samochodowego jest w posiadaniu 2 manekinów niechronionych uczestników ruchu, pieszego oraz rowerzysty. Sprzęt wykorzystywany był na torze w Ułęży do badania systemu automatycznego hamowania awaryjnego oraz adaptacyjnego tempomatu. Podczas prób zbierano dane dotyczące dynamiki ruchu pojazdu. Dzięki temu możliwa była analiza m.in. prędkości, czasów do kolizji, momentów wyświetlania komunikatów dla kierowcy, czy też dystansu do makiety po wyhamowaniu pojazdu.
Symulator samochodu osobowego wysokiej klasy dzięki ruchomej kabinie prawdziwego pojazdu oraz otaczającemu ekranowi pozwala na realistyczną symulację jazdy po dziesiątkach kilometrów dróg dowolnie projektowanych z udziałem wielu innych pojazdów i w różnych sytuacjach od usypiających po niebezpieczne, a nawet awarie. W symulatorze możemy prowadzić szkolenia kierowców w różnych porach dnia i nocy, w różnych warunkach pogodowych. Możemy sprawdzać, jak stan kierowcy, np. jego zmęczenie, wpływa na reakcję. Możemy także prowadzić testy infrastruktury drogowej i badać nowe systemy wspomagania kierowców. Takim systemem jest Highway Chauffeur, który utrzymuje samochód w pasie ruchu, dostosowuje prędkość do warunków na drodze, pozwala na automatyzację zmiany pasa i może ostrzegać kierowcę przed niebezpieczeństwem, a nawet może zatrzymać pojazd w przypadku braku reakcji kierowcy.
Centrum Kompetencji Pojazdów Autonomicznych i Połączonych to jedno z większych osiągnięć Instytutu Transportu Samochodowego. Powstało z połączenia zaplecza badawczego, jak również wieloletniego doświadczenia ekspertów Instytutu. Ma za zadanie wspierać administrację rządową w zakresie implementacji europejskiego prawa, w tym przez udział polskich ekspertów w międzynarodowych grupach badawczych, ale ma też być krajowym punktem kontaktowym. Dodatkowo ma na celu koordynację i monitorowanie przestrzeni badawczo-rozwojowej zarówno w obszarze publicznym, jak też i gospodarczym.
W ramach przedsięwzięcia planowana jest rozbudowa zaawansowanego zaplecza technicznego, jakim dysponuje ITS, a także utworzenie infrastruktury umożliwiającej pogłębione badania technologii wspomagających rozwój automatyzacji transportu drogowego. Dalsze kroki będą koncentrować się na rozbudowie zaawansowanego systemu monitorowania aktywności i uwagi kierowcy, dokupieniu manekinów, a także platform jezdnych oraz uzupełnieniu zaawansowanych stanowisk symulatorowych o moduły umożliwiające szkolenie kierowców z bezpiecznego wykorzystywania zaawansowanych systemów wsparcia kierowcy.
I tym samym
And this is how at AV Poland 2021 we have inaugurated the Center for Competence in Connected and Automated Transportation. Nonetheless, the Polish road to transportation is also about putting on the brakes. We are going to now hear from Małgorzata Pędzierska, the head of the Autonomous Vehicle Studio at the Institute for Motor Transport. She will talk about how putting the brakes on is one of the fundamental issues to be considered. Ladies and gentlemen, my name is Małgorzata Pędzierska. I am the head of the Autonomous Vehicle Studio at the Institute of Motor Transport. Today I am going to be talking briefly about the results of research we engaged in virtual and actual traffic. Our research were a source of skills and knowledge and know-how, both on behalf of our own institute and the consortium as such. Today I'm going to be talking about selected fragments of the analyses we engaged in. I would like to talk about some of the findings, focusing on emergency brakes and cruise control functions. The purpose of our research was to expand our knowledge concerning the functionality of selected and most common systems of driving assistance. Moreover, we decided to focus on the development of substantive backdrop and background facilities in order to improve road safety in Poland. We used a testing track, and we also analyzed actual traffic. We focused on the selected group of drivers, including the functionality of system handling by people with motor impairment. We performed our track studies at the Ułęż track, main lane 30 by 1400 meters. We also introduced a number of traffic signs, horizontal and vertical. We put up static and dynamic vehicular mock-ups you can see a static vehicular mock-up on the photographs, allowing us to test emergency braking. All vehicles were made of lightweight materials, protecting vehicles from damage to the chassis. Now, using the Euro NCAP EVT mock-up with the Flex Motion EVT towing, we tested the behavior of vehicles at speeds up to 50 kilometers per hour. We used mobile systems of data acquisition. We collected data from 2 vehicles, which enabled us to collect data concerning the moment of message sending, the moment of collision avoidance, speed of the vehicle in motion. Now, in terms of the systems we researched, I'm going to focus on the automatic emergency braking system and the adaptive cruise control. We also focused on the system of warning of the blind spot object presence, the system of recognizing traffic signs, as well as driver's assistance systems in general. In terms of test situations, we designed 4 testing situations. We placed a vehicle, on a collision and non-collision track. Now, under test C, the mock-up was set up on the collision course along a curve, and during our last test, it was placed on a non-collision curve along an arch. For purposes of all tests, we performed, for purposes of each scenario, we performed a number of tests. We sped up the vehicle to considerable speeds. Now, at such speeds, vehicles should signal obstacles or begin the emergency braking procedure. Some vehicles should also notify the system prior to the event, prior to the occurrence, and begin braking. You can see the reactions of the systems for the first three situations where the mock-ups were set up on a collision course. Such had been the expected system response. The response was there. The collision and braking response was present in 30% of the cases, whereas in 58% of cases the systems did not respond to warnings, despite the fact that the mock-up was well visible. We also analyzed the moments of responses from the driver's perspective. It was even a seventh of a second prior to the occurrence. The response time, the reaction time, in a very alert driver spans a time of 0.7 of a second to 1 second, which means that the system proved to be better than even the most alert driver of all. We have also noticed that among all the factors impacting system operation had included obviously the condition of the sensors, but also weather conditions as well as lighting conditions, for example, the refraction angle. Now, along the arch, all systems actually passed their test, and as expected, there were no reactions to the occurrence. As I have told you before, we also performed studies in actual traffic on the expressway S8 along a total length of 38 kilometers, at least 2 lanes each direction, well visible horizontal traffic signs. Moreover, we also performed all our tests with traffic intensity, allowing us to do that. We tested 30 active drivers aged 30 to 45 years of age. We also considered senior drivers 55 years of age and above, plus persons with audio and or motoric disability, 5 drivers to be specific. All drivers that we tested are active drivers, driving several times a week, and some of these drivers traveled more than 1,800 kilometers per month. The research procedure spanned a number of steps. Firstly, preparation for research. We had to notify our participants of the purpose of the study, ask him or her to fill out a questionnaire. We also organized a brief training in the guidelines. The person participating in the study was informed how the system works in order to be able to handle specific situations. Moreover, we also organized adaptation drives, test drives, in order to enable us to switch the system on in individual vehicles. We wanted to find out how the system works and how the systems actually switch on. We also asked whether our test drivers, our participants, are fitted, whether their vehicles are fitted with such systems. All drivers told us that they do not have such systems on board. Nonetheless, they have all said they heard of such systems. They either read about them or heard about them from commercials or in commercials. We also had a vehicle tracking solution. We can see that our vehicle is traveling at stable speed. Once approaching the preceding vehicle, the speed drops. The car decelerates in order to avoid collision. In second 41, we can see that the preceding vehicle changed the lane. Free space appeared in front of our test vehicle. You can see that at such point the speed picked up in order to reach the pre-programmed preset speed. You can see the graph for speed curves. This is a collective result for all vehicles. You can see that nothing happened for 2 or 3 seconds when the preceding vehicle changed the lane. Vehicles did not automatically pick up speed. They only sped up later. You can see the differences in intensity for the assorted vehicles. Persons using cruise control can also set a distance separating him or her from the preceding vehicle from a scale of 3 to 5. Nonetheless, there is no option of changing the intensity of braking, for example, which definitely may affect the sense of comfort and safety in the driver. You can see the graph showing the curve of the vehicle picking up speed to 50 and 70 kilometers per hour, respectively. You can see that at 50 or 70 kilometers per hour, the speeds became stable in roughly the 12th second. Vehicles needed some time in order to stabilize the traveling speed. Now, we also tested vehicles cutting in at a similar speed. We had, with the cruise control on, we maneuvered a vehicle into a lane where another vehicle cut in, which means that emergency braking was enforced. And you can see the intensity of braking for individual vehicles. You can see that the results were different for different vehicles. In case of some vehicles, the braking maneuver was quite intense. The entire braking maneuver was performed over a span of 6 seconds, whereas in case of vehicles with lower braking intensity, the braking time reached 10 seconds, which definitely affected the sense of comfort and security in drivers. The higher the braking intensity, the higher the chance, the opportunity for our vehicle to slow down and avoid a collision. But yes, it is true that it may increase the sense of discomfort in the driver. We also measured or tested the sense of comfort and security. Now, the participants of the study were quite comfortable in what was going on, but there was also a difference in conditions perception by drivers. People who could not affect the driving mode. Drivers who could take over declared that system responses were acceptable and made them feel secure, whereas the passengers' response or sense of security and discomfort was slightly different, which may definitely translate into the future reality of autonomous vehicles. We have also analyzed the level of difficulty in vehicle handling. Before we handled a rather large group of drivers of vehicles. After the test was over, we asked them to tell us how they managed to handle the systems on board. We asked them to respond. The majority of drivers told us that they found the system to be easy or very easy, and nonetheless, the person in the passenger seat had a slightly different sense. It responded slightly differently. Drivers deactivated the system by pressing the brake pedal, not realizing that the car is now no longer traveling in cruise control mode. So that definitely proved that we do need training evolutions in order to teach drivers how to monitor the system, in order to make them realize how everything, in what way everything happens. Drivers will definitely need to test their skills. The lack of skills is definitely one of the reasons for the number of traffic accidents. Now, with regard to keeping the car in the lane and monitoring the blind spot, in both areas, drivers declared that that was rather easy for them. Now, we have also noticed the differences in adaptation time in experienced and non-experienced and experienced drivers. People who are more experienced, they had no problems with adapting to the system. Now, you can see that what you can see here is the sense of comfort when using the driving assistance systems. You can see what the responses were immediately after the system kicked in, and after some time, the majority of our participants declared that immediately after the system kicked in or after a short driving time, their comfort levels increased in a given situation. Now, I'm now approaching the conclusion.
Państwo widzieli na torze.
As you saw on the track, those systems don't always work as expected. And in spite of what the manufacturers say in the manuals, which tend to be very long and they discourage people from reading them, those systems aren't perfect. So we have to remember that it is always the driver who's responsible for taking over control over the vehicle and saving the day. And this is something we have to keep emphasizing and making the drivers aware of it. And that's why we need training in order to tell the drivers how to properly use these systems and to show them how they operate in real life. We know that the human factor is the single most important factor behind road accidents. So these driver support systems can improve road safety, but some more work needs to be done on them. For example, we often saw that, let's say, another sensor would be needed to improve the resilience of the systems in terms of different weather conditions or different light levels. But if we use them without having the correct knowledge, the effect can be opposite. In fact, instead of increasing road safety, we can decrease it if the drivers don't focus and trust the systems alone too much. Thank you.
I tym wystąpieniem magister inżynier Małgorzata
Ms. Kędzierska from the ITS, and her presentation concluded the first part of the conference on AVPL Road. However, this is an international conference, so there are many other sections and segments in this conference. We have some experts from the Visegrad Group present in a remote way, and some experts who will talk about Horizon 2020 and the projects that are financed as part of that program, that include, among others, programs designed to increase the drivers' awareness and trust in these systems, and also training, which, as we have just heard, are necessary to use these systems correctly. We'll be back after a short break with the second session on AVPL Road. I'll see you soon.
Dzień dobry, miło Państwa.
Good morning. It's a pleasure to see you, not so directly perhaps, but on the other side of the screen. This is our conference where we are talking about autonomous future for transport in Poland and elsewhere. Now, this is the AVPL road, the Polish road towards the automation of transport. And the second session with Sławomir Lewandowski from Innovative and Sustainable Mobility at the Infrastructure Ministry is going to talk about how these solutions are being implemented in Poland and will analyze the legislation. Good morning. My name is Sławomir Lewandowski. I work at the Transport Strategy Department at the Ministry of Infrastructure. And I would like to tell you about the analysis of the legislation that makes it possible to implement autonomous vehicles and also testing them in different parts of the world. My presentation is based on a report that we have developed that analyzes the situation in the years 2019 and 20, and it takes into account all the necessary preconditions for a coordinating body with respect to the implementation of automation in a country. Now, the report covers the whole world, or I should say it pertained to the countries where legislative work was the most advanced. On top of that, we have the EU acquis and international laws. But we mostly looked at the top 10 countries in terms of the autonomous adaptation, as it's called. And the situation hasn't changed that much since this autonomous vehicles readiness index is pretty much the same a year later. And we looked into a single Asian country, Singapore. We looked at the US, both federally and individually at California, Florida, and Texas. And we looked at 6 European countries, including Poland. That obviously was the most important aspect for us if we wanted to compare and contrast. We focused on the things that, from the point of view of a coordinating body, are key. First of all, we looked at the rules and the principles of testing of autonomous vehicles. We looked at whether AVs, autonomous vehicles, are being introduced to real traffic. We looked at the homologation rules, which is a very important element of our research. Insurance was another important element that is of significant importance. We looked at training requirements for drivers or anyone who will be involved in implementing automation on the roads. And in addition to all that, in addition to all these hard solutions like legislation, we also looked at ethical aspects of automation in road transport. And we also added some elements of public awareness. Now, it will come as no surprise that in most of the jurisdictions there's a requirement of first obtaining a permit to conduct tests with the use of an AV. Florida, Texas, and the United Kingdom are alone among these jurisdictions that don't have this requirement, but their solutions are slightly different in some details. I'm going to come back to this later. Most of the countries we studied make it possible to carry out autonomous vehicle tests without a driver inside, but some of them precondition that on first obtaining a special permit for a test of that sort. And then supervision is guaranteed by a constant connection or link with the car and the vehicle being specially marked to make it easily identifiable on the road. And also there has to be a kill switch available to stop the car. Now, importantly, some additional requirements from different legislators for any testing organizations is that the drivers and the operators of autonomous vehicles have to be properly trained. In some jurisdictions, a video recorder, or what's called an event recorder, is necessary to make sure that if any incidents happen, you can recreate the situation. Singapore is an interesting case because there has to be an online connection from the black box in the vehicle with the supervisory body throughout the test. Now, to sum up, the studies we have carried out have shown that the overarching objective behind the legislation is to ensure the safety of these tests. In other words, information about the effects of the test have to be obtainable in a safe and secure way. Now, looking at Poland, what's important is that, as we have been hearing from testing bodies in Poland, a lot of emphasis is put on prevention. And perhaps we should change our attitude. Maybe we should make testing a bit easier, following the example of the countries that focus on ensuring the safety of the test itself. Now, autonomous vehicles in real traffic. This is the most interesting area. Everybody would like to have a go and see what it looks like in reality. Now, experts have been testing these vehicles for a long time, but I'm talking about users, so the participants in road traffic. Now, this isn't easy, and there are many hurdles. Now, the solutions we have in place at the moment are of a transitory character. And this is not a surprise. The current technology is also transitory, and we cannot plan ahead long term in terms of all the different elements that make autonomous traffic possible. For example, the UN has reached a compromise about it, and Regulation 157 makes it possible to use an autonomous lane control system on motorways as long as the speed of 60 kilometers per hour is not exceeded, which naturally is extremely slow on a European motorway. Germany will probably follow these rules too, but they introduced laws that make it possible to use level 4 autonomous vehicles in motorway traffic, and they said that these rules will be made more lenient when these vehicles are already available on the roads. Now, looking at EU legislation, there are two elements here. We have the what we call homologation for the car, and we've got infrastructure safety. Now, the EU is now amending its regulations. Towards the end of this year, the member states will have to implement the directive on the safety of road infrastructure, where emphasis is put, for example, on the road signs being easy to read for the automated systems, not just for the drivers, but also for the systems. Now, about homologation, these changes will come into force in about a year, and emphasis is going to be put on using all the different systems. And there is a definition of the systems that make it possible and easier for the vehicle to communicate with the outside world, and how the vehicle gets its information about the traffic, how it communicates with the driver, and also some standardization solutions for data exchange. Now, the most important change happening here is that we have a definition of an automated and fully automated vehicle. It's a vehicle that has been manufactured and adapted to temporarily driving without user control. With a fully automated car, it's a vehicle that can move around without any supervision from the driver. Now, this is controversial looking at global regulations. Changes in Vienna Convention do not allow for this sort of solution, so we will keep track of what's happening with it, and hopefully we'll be able to effectively prepare for the upcoming changes. Now, the Polish approach is based on the safety first principle. We want to use solutions that are mature, tried and tested, and that ensure safety in road traffic, especially during the long stages of mixed traffic. This will be particularly important. Now, I've mentioned homologation before, or type testing. We will talk about it at more length later on. But this is absolutely key if these vehicles are to be seen on the roads. And also Regulation 157 from the UN is the first international sort of rule. Now, this does not apply to the states. The USA is not party to Vienna Convention. In the EU, on the other hand, we have the 2019/2144, which is a regulation that amends type testing and homologation for vehicles. Then we have some attempts at introducing a road safety classification and to what extent a given road has been adapted to autonomous traffic. There's been a proposal of a 5-tier system to classify roads, starting from F, which is your standard analog road, all the way to Class A, which is fully compatible and it collaborates with the vehicle, and the infrastructure on a road like that provides all the necessary information to the autonomous vehicle to make it possible for it to drive using the supporting systems. Now, the C-Roads group is very important here. It's a group that brings together 14 EU countries, plus the UK, plus Norway. And there's the private Car-to-Car Association that is standardizing communication and data exchange. And these two working groups collaborate and exchange information. And any future builders of infrastructure will be able to use these rules and guidelines, like for example in the Polish road traffic management system, which will start testing smart transport systems in some time.
Now, the question that we are asking ourselves in terms of legislation and or organization is as follows. Don't we see a need of introducing supplementary homologation requirements in terms of local infrastructure, given the given the fact that a lot of time will have to pass before we have uniform traffic sign related regulations across the EU, for example. So the question is, how will an automated vehicle behave on international roads? Insurance, that is definitely a topic that would merit its own separate conference. Now, insurance is most usually allocated to individual member state. The EU law does not regulate that. We had Directive 209/103 orders individual EU member states to regulate these matters on their own merit. Now, in terms of test and testing, the situation is much more dynamic. Vehicles have been undergoing testing across EU countries, and most vehicles will require obligatory insurance for testing. The Netherlands are an exception here. Such insurance is voluntary, although the local authority may demand that insurance is taken out. In Poland, the situation is debatable. Although the insurance requirement is absolute, the question remains whether we ought to take out limited or full insurance. We believe, we have concluded that two insurance policies ought to be taken out. It goes without saying that this is through the driver. Nonetheless, they will definitely increase safety levels and security levels. The UK solution is hugely interesting. We are definitely going to follow it as the project unrolls. The British do require AVs to be insured. Nonetheless, it is also required that the insurer will be required to pay compensation to any damage filing parties according to absolute rules. The 1.2 million of pounds sterling is the contractual cap. Nonetheless, the British drivers may be absolutely certain that insurance will be paid out in case of any traffic incident or accident. Just a bit of trivia, if I may, in terms of insurance thresholds across the board. In Texas, US, for example, Texas has a cap of 1 million and California has a 5 million cap. In Singapore, for example, there is a 1.5 million Singapore dollar cap for purposes of AV testing and AV testing consent. Now, in terms of preparing drivers or operators for AVs, the question is truly whether we are talking drivers or operators here, or are we talking about a broader scale or range of the phenomenon. Obviously, AVs require a totally different set of skills in terms of behavior responses. We do know anybody using the cruise control will know what I'm talking about. Obviously, all these systems will require drivers or operators to be trained. Today, individual EU member states are testing and seeking solutions. I believe that the Netherlands are now the most advanced. They are considering an extra driver's license to be introduced, or actually an AV operator's license. We are now making efforts in order to make the entire chain of traffic more efficient. We are working with drivers or operators with AVs. We are talking to drivers using support vehicles. We are also talking to traffic inspectors. All these groups of professionals will have to acquire extra certificates. The topic is really interesting. It is definitely a future-oriented topic, and it is one that we will be focusing on at different and consecutive stages of our project. Briefly about data, we have already been talking about data here. I'm going to limit my comment in this area, in this field, to just a few sentences. Traffic safety is not only about free access to amazing amounts of data. It is also about personal data protection. That goes without saying. It is also about protection against cyber attacks. And I'm not only talking about the diligent process of selection, of selecting your 5G operator. That is a process that has just kicked off. It is a discussion concerning the involvement of big data providers, not to mention the fact that we will have to focus on other issues, such as, for example, deep learning and big data handling and other topics that will require extra legislation. At the level of the European Union, those processes are extensive, not necessarily designed for purposes of transport specifically, but obviously recognizing that industry. The same situation will take place in Poland. In terms of transport, we are going to be federalizing the national points of access to data. We are going to be enabling data flow in order to make AV traffic flow as efficient as possible. Ladies and gentlemen, now the issue of transport automation is does not only tie in with legislation. Some people believe that laws are for lawyers. You can see that my presentation includes a rather subversive quote concerning the use of AVs in the future and what it can involve. It is a quote from an American neurobiologist from Stanford University, who, when analyzing the issue, talked about free will, and he compared the human brain to a car. And then he said jokingly that you can obviously hand controls over to the system, and if we decide to program the machine ourselves, we might be surprised in the future. Now, Sapolsky's joke is not the only approach of the kind to the issues. The scientists from the Oxbridge Center for Researching Existential Risk, actually Oxbridge, from the two leading UK universities, concluded that human behavior is a result of a number of factors. Now, the question that we need to ask is whether the amazing consequence of the machine that is meant to be 99.9% correct will not surprise us, in particular in traffic conditions, in road traffic conditions. I would like to emphasize that under such conditions, the hybrid road traffic will only be based on the level of consent, of social consent to the use of decision-making machines, not necessarily on the level of advancement and maturity of technologies available at a given point in time. In summary, to recapitulate, I would like to say the following. Questions that we asked could seem obvious and tie in with areas that we all know. We have not responded to all of these questions. Probably most of the questions remain unanswered because we are still dealing with an experiment. We are going to continue with our analyses. We are going to continue analyzing the option to introduce future or further legislation. We will also be working on social or public awareness in Poland. And let me risk the following thesis. We are going to be making our AV implementation decisions not in terms of legislation, but rather on the basis of social consent to such activity. Thank you very much. As we have just heard, we may definitely expect a lot of changes and a lot of work before we reach a stage when AVs will be able to hit Polish roads. This is something that we are talking about today during AV Poland 2021. If you want to ask any questions of our experts, you can ask your questions on the chat. Our experts will be more than happy to answer them, including experts from the University of Warsaw University of Technology, Iwona Grabarek, Andrzej Czerepicki. They are and Sylwia Bęczkowska. So we have Dr. Sylwia Bęczkowska, Dr. Andrzej Czerepicki of the University of Technology. They are going to be talking about the comprehensive diagnostics of transport automation issues. Good morning, ladies and gentlemen. I represent the Warsaw University of Technology. We are the didactic staff of the Faculty of Transportation, and we have joined forces with the Ministry of Infrastructure and the Institute of Motor Transport to deliver the AV road project. I've, in my work, focused on the ergonomy of technological devices in the project. I am the head of the Department of the Mechanic and Mechatronic Systems in Transport. My colleagues are also members of that particular department, thanks to which we can work on the project together. We are going to be delivering the speech as a trio. The topic is interdisciplinary. We decided to pick experts for each of the topics involved. The agenda, as you can see, is rather brief. We have a limited time. Let me tell you why the Green Book was introduced at all. Let me also discuss the range of topics discussed. We are obviously only going to be talking about selected topics, following which I will offer a couple of words of summary. Let me tell you why the Green Book and why it was introduced. When launching the project, we concluded that we ought to find what is the condition of the matter globally. Obviously in Poland as well, but I think we are going to be drawing most of our knowledge from the know-how and achievements of our foreign partners. We have decided to collect and analyze problems concerning automation. We have decided to also find out how automation will affect the environment, public safety, and the society. As a result, we put together a comprehensive diagnosis of the road traffic automation problems. We have been continuing problems dealt with before by the Warsaw University of Technology and the Ministry of Infrastructure, as well as the Institute of Motor Transportation. We all know that we will need to resolve a number of complex problems. We will have to correlate the position of the vehicle with the current roadmap. We will have to find out how vehicles identify other vehicles. Now, the driver's role is very important as well. Automation is incomplete. We are not yet a passenger. Now, the decision-making concerning maneuvers and making them, it is also a very important matter, as is the approval of vehicles for traffic. Legislation was already discussed by my predecessor. Now, there are a number of problems that will have to be resolved. Obviously, a number of issues have to be discussed and debated and resolved. Now, as part of the works undertaken by my department, my faculty, we focused on technological issues involving IT, sensors, and the human factor. We believe that the human factor is hugely important to any vehicular systems, not to mention communication systems and the approval of AVs for traffic. We will try to focus on all these matters. I will focus on the human factor in AVs. Now, the simplest classification will tell us how the systems change. Today we have hit level 3. I believe that levels 4 and 5 are wishful thinking, albeit level 4 is now being introduced here and there. Now, level 1 allows us to introduce systems that turn us from a driver to a monitoring entity. Regrettably, from the viewpoint of the driver or a human being, the monitoring functionality is not the best one of all. Consequently, it is worthwhile considering what kind of factors may impact driver operation in AVs. Before we hit level 4, I believe that we are still a driver in an AV. We are not yet a passenger. Now, when analyzing a variety of research and studies, we can identify a number of components and factors that will definitely affect the effectiveness of drivers functioning in cars. It is all about being alertness and/or distractions, because drivers are now engaged in a variety of secondary tasks. They can actually do that during the transition period. The vehicle will be self-driving, self-operating. We need situational awareness, human in the loop. It is very important because once drivers engage in a specific set of activities, they withdraw from the driving loop. They are not always aware of what is going around them. So-called passive fatigue may also kick in. Now, with regard to the system itself, the underload or overload is equally unfavorable for operators. Nonetheless, we have not yet completed our research to answer the question to what extent automation will affect that factor. Now, behaviors are very important. Behavior has also been discussed in questionnaires addressing potential AV users. Obviously, we may be confident, we may trust the vehicle, we may trust it fully or not at all. Neither of these situations are desired. The trust and confidence are a function of time and experience. Unfortunately, self-satisfaction is another factor. Once we find that a system is fully reliable, we are going to stop actively participating in the monitoring process, which obviously may bring undesirable results. Last but not least, skills. It has been forecast and projected that we have actually lost certain driving skills. If we decide to not drive at all, we should attend refresher training in order to be able to take over control over the car. According to Alliance Center for Technology, 63% of drivers in Germany use navigation when driving, 61% browse the radio, and 43% browse complex menus on onboard computers. Obviously, such distractions are the fundamental cause to accident. In 80 to 90% of all accidents, humans are the main reason behind them. Now, we are also talking about the acceptance for new technologies. Research has proven that we have problems with voicing such opinions for a very simple reason. We have limited access to those vehicles. Consequently, we do not know a lot about them, so certain decisions concerning autonomy and autonomy-related factors are an issue, are a problem. We are also obviously aware of potential legal and ethical barriers. We fear the loss of privacy, since vehicles are going to be collecting data. The inevitable question arises, what about us? To what extent can we remain anonymous? Now, in general, people speaking out, and well, our respondents, 50% of our respondents do not really have great trust in the complete reliability of AVs. Nonetheless, the differences are definitely there in terms of gender, experience, and affluence. The higher the age of a driver, the less he or she, the lower his or her propensity to drive such a car. Now, from the viewpoint of AVs, the control transfer is a very important factor. We are still part of level 3. Consequently, the control delegation is a two-way process. The vehicle may hand over control to the driver may hand over control to the vehicles. There are certain criteria and requirements that have to be met. The problem remains unresolved, how to design the process of the driver taking over.
I to on jest tym najbardziej jakby zawodnym ogniwem w tym całym systemie i trzeba się.
Now, this is the weakest link in the system, so we have to adapt to how we operate as humans. For example, we have to know when our reaction time is the fastest and how the system should give the information to the driver about this moment coming up. So that ties in with the structure of the interface, what information is the most pertinent at that particular moment, and that sort of thing. So no matter how we design the human-machine interface, training will be necessary. Everybody knows that we have many convenient things in the cars we drive, but we often don't use them because nobody explained to us how to use them. Now, the HMI interface is a crucial element because it is it that ensures the contact between the vehicle and the driver. So this is how we need to design it. It has to be intuitive and tasks should be performed by it in the correct order. The amount of information displayed should be kept to a minimum because too much information does not make things easier. On the contrary. And it should hint on which functions should be used when these functions are needed. Multimodal interfaces, integrated interfaces, and so-called conversational interfaces are proposed as the solution of this need. Apparently, conversing with the machine is perceived the best. Now, we need to develop cohesive training and testing programs for drivers before they start using the L3 and L4 vehicles. We also need to study how drivers behave in different situations. For example, well, you can do it on simulators, but the simulator doesn't really reflect the real conditions. Now, training procedures should be used using real facilities. The driver should understand what his or her role is in the vehicle, what potential threats might appear, so that in a crisis situation they are able to make the right decision, which is what you do in pilot training programs. So we should use the experiences from pilot training, and then manual control can be reinstated immediately. And finally, awareness raising and persuading the public and the decision makers to follow this path. As the previous speaker said, to a large extent it's up to all of us and how we understand the need of these new technologies being implemented. So this is it. Thank you very much. And it's over to my colleague who will continue.
Dzień dobry Państwu, życzę.
Good morning, ladies and gentlemen. I represent the Transport Department faculty at Warsaw Technical University, and I would like to talk about networking solutions in autonomous vehicles. It would be difficult to imagine automotive autonomy without connection with other cars, the road infrastructure, and other participants in the traffic nearby. Automotive internetworking is the way we define this network that brings together different vehicles in order to allow them to exchange data, and also with road infrastructure. Automotive internetworking depends on what we want to connect. For example, if we want for cars that are close by to be able to exchange data on the current road situation, then that's what we call V2V, or vehicle to vehicle. Sometimes it's called C2C, or car to car. Now, in this architecture, the cars exchange information on the current road conditions. For example, some warning about an upcoming maneuver, or information about a privileged vehicle coming up. If our automated or autonomous vehicle is to use the information from the road operator, then we need the vehicle to infrastructure architecture. Now, in this kind of infrastructure, we have a global communications network with the elements of the infrastructure nearby. So this is a distributed computer network where we collect data from different devices that monitor traffic intensity, for example, or the pedestrian crossings and other factors. Now, this information is complemented with the data from the sensors in different vehicles on the road. So this information is cross-validated from different sources, and then reliable information about the situation on the road is distributed back to vehicles. Now, autonomous vehicles and vehicles at different stages of automation can be participants in the automotive internetworking regime. This also includes the road operators, the drivers, and car manufacturers who would also like to collect data on how the cars are used. Repair workshops as well, and others. Then we have a vehicle to pedestrian architecture that includes pedestrians who are unprotected participants in road traffic. So we have the standard elements like a pedestrian crossing, but there could be an app installed in a pedestrian's smartphone that would indicate that this person is coming closer to a zebra crossing, and this information will be sent to the drivers nearby. And the pedestrian will also receive a warning. About communication, well, naturally, these are wireless communications systems, GSM, first and foremost, and also Wi-Fi. Now, for close connection, no, short-range communication, or DSRC, Wi-Fi has traditionally been used, for example, because of how you can connect to them quickly, and that it's very easy for different vehicles to either connect or disconnect from the network. Now, in the vehicle to infrastructure, mobile telephony was the main factor. Now, with 5G, message delivery times have been cut. So 5G networks are now being used to create ad hoc vehicle-to-vehicle networks. And the wireless Wi-Fi technology is also developing. ITS-G5 is a new standard that has been around for a few years, and that is used in the vehicle-to-infrastructure system. So these are the two standards. The latter is being promoted by the European Commission more, but we'll have to wait to see which one prevails. An autonomous vehicle on the road is equipped with different sensors, of course. They are used to collect information about its immediate surroundings. These are well-known types of sensors like video cameras, radars, or LiDAR, as we call them, or laser radars, so to say. Now, each type has its pros and cons. Now, video cameras give us a picture which is like what a human being can see. So the picture has to be digitally analyzed and processed to, for example, detect other participants in the traffic, and also to detect different classes of objects. Now, this has been used in the motor industry for a long time, so that doesn't really impact the price of a car. But the data from video cameras depends to a large extent on the weather conditions. As a result, an autonomous vehicle must necessarily have radars. The weather conditions are no longer an issue, and we can detect objects that are approaching. We can calculate the exact speed using physical phenomena that radar makes use of. So connecting video data with radar data will make it possible to recognize what kind of object it is, classify it, and tell us what direction it is moving in. And finally, LiDAR, which is a pretty modern device. I mean, it's been around in industry for a long time, but they have only recently appeared in the vehicles because of their size. And they have to be compact, and the price is rather high. It's basically a laser scanner that's used to build 3D maps very quickly. LiDAR has very high frequency, and while it might not recognize the color of an object, it will be able to calculate the exact distance, and it has very high angular resolution, so it's much more exact and accurate than radar. But again, LiDAR can be impacted by adverse weather. So it's all about a fusion of the different types of data from different types of sensors. I've forgotten to mention infrared cameras or ultrasound sensors that have been used in cars for a long time. So all of these taken together and merged will make it possible for us to have a full picture of the situation on the road. Now, LiDAR is probably the most interesting sensor you can use in a car. Like I said, making them small enough was the biggest challenge, and also reducing the costs. Until recently, people were debating whether LiDAR should be used in cars at all, or that perhaps video cameras would be sufficient. If we analyze data from 2 years ago, we can see that the development of LiDAR has been progressing very quickly, and it certainly has to be used in cars. Its price is no longer a very significant issue, as opposed to a camera and radar. Everybody knows how they work. Now, LiDAR can be done using different concepts. Some of them are like a camera. They register the whole picture and use reflected light. But there are other kinds of LiDAR that have a head that scans a particular point by sending laser impulses. They can employ a special mirror or a set of optical elements that is used in some types of LiDAR. Now, about the positioning system. Establishing the exact position of the car entails using traditional systems like GPS, for example. And add GPS and GPS RTK makes it faster and much more accurate, with an accuracy of several centimeters. We also have inertia navigation. For example, when the car comes into a tunnel and there is no GPS signal, but we have to know where we are in this enclosed space, so we use accelerometer to measure how acceleration changes, and thereby we can establish our position. In underground car parks, we can use wireless positioning system, for example, which establishes the position of the car based on, for example, how long it takes for a signal to come to the car from a transmitter. Now, about how LiDAR is used. The issue of building a 3D map is interesting in itself, and how the vehicle can be, how its position can be established in that map. This is called SLAM, simultaneous localization and mapping. And there's a lot of mathematics behind it. At our faculty at Warsaw Technical University, we did some research on this and we developed software to use LiDAR. So we've been through all this, which was a bit of an experiment. But what I'm driving at is that there are maps developed in many countries that include such elements as the road lanes, road signs, and others. For example, we have TomTom's DNA road mapping that includes several layers. Data is collected from the LiDAR, then it is filtered. Elements that change with each drive-by are eliminated so that only static, only constant elements are kept. And this includes, for example, road signs and other information signs, also the horizontal signs painted on the road, for example, how the road is divided into lanes. All of that is stored in a cloud, and it gives us an accurate map of the surroundings that a car can use afterwards. Now, getting closer to the end of my presentation, let me just wind up by saying something about machine learning that can be used for autonomous vehicles. You all know that the main pillars of machine learning is that we have to have the data, and we do have the data from the sensors of those autonomous cars. We have a lot of data, in fact. To process them, we need to have the right computing power. And again, we have these computers. For example, NVIDIA has developed a special platform for autonomous vehicles. Then we need to have the right software. Now, when there is uncertainty about the decision that an autonomous vehicle should make, the prevalent opinion is that we should be using machine learning. The so-called deep learning is being used at the moment. So the discussion is whether we should first recognize things from LiDAR separately, from the camera separately, and then that should be put into the neural network, or whether we should have what we call end-to-end learning, with all the data being fed from the sensors, and then the vehicle would make its own decisions. Now, the main challenge is that this decision would be difficult to verify and to substantiate, to tell why the vehicle made this particular decision rather than another. So a lot remains to be done, but it's going in the right direction.
Państwa, wszystko.
Well, that is all from me in a nutshell. I just described a number of chapters from the Green Book. Thank you very much for your attention. Good morning, ladies and gentlemen. Similarly to my colleagues, I represent the Department of Transportation of the Warsaw University of Technology. My name is Sylwia Bęczkowska. There would be no Green Book, ladies and gentlemen, without legislation and proper analyses of fundamental issues tying in with legislation. All reports have been put together and have been made part of chapters 7 and 8 of the Green Book. They focus on legislative issues concerning self-driven AVs. They contain references to scientific writings as well as legislative solutions. Governments across the world will have to resolve complicated legislative matters pertinent to complete vehicle autonomy. Ladies and gentlemen, what kind of challenges are we talking about in terms of governments across the world? This slide lists a number of selected issues. One would be hard-pressed to discuss all of them. The first question is, who is going to be considered the pilot of an AV? Who will respond for any traffic rule violations? How should authority be distributed between the driver and the system in terms of driving and in terms of controlling tasks associated with driving a vehicle? What kind of status should be assigned to the driver on individual stages of complete automation? Who will collect data? Who will guarantee cybersecurity? How should road infrastructure be adjusted to the system? Not to mention accident insurance or homologation. Over the last 2 years, 2020, 2021, we were obviously facing the pandemic reality. The economy of the world came to a standstill. Nonetheless, the autonomy and automation related changes had experienced amazing progress. We have listed a number of countries with their centers: Australia, Canada, China, Germany, Hungary, South Korea, and Poland, as well as Turkey and the US, are countries whose centers had recorded amazing progress. Let me discuss selected issues. Let me start with Canada. The Canadian federal government had focused on the guaranteeing of cohesion against all jurisdictions, whereas in terms of provincial, territory, and municipal governments, well, they made steps. They took action to promote AV development. In Ontario, companies have to secure permission according to the pilot project of AV in Ontario rules in order to introduce levels 4 and 5 of SAEs on their roads. The same thing goes for Quebec. They are discussing levels 3 to 5. I would also want to discuss China, Australia, and Germany. In Germany, in November 2020, the Ministry of Industry and IT published the recommended standards for legislation. In Australia, the Australian National Transport Commission published their guidelines in 2021. Germany intends to be a pioneer in the automation race, which is why several days ago they actually signed a piece of legislation, an act of law, designed to introduce autonomous vehicles as early as 2022. It is being said that those vehicles will be encountered on highways and expressways. The driver will have to be on site in the car and will have to be sitting in the driver's rather than passenger's seat. Hungary and the US. In Hungary, the policy comprises analyses and supporting the vehicle-to-vehicle communication environment. The government has committed to create a number of roads involving specific technologies by 2025. In the US, the plan of the previous president is being continued, but also Joe Biden's plans involve the protection for users and communities, promoting effective markets and promoting coordinated activities. In Turkey, the Ministry of Industry and Technology focused on the resolving and introduction of legislation concerning homologation of new AV vehicular types. In all probability, the regulation will be passed on July the 6th. Now, Southern Korea passed an AV Act of Law last year on May the 1st, 2020. The Act of Law provides the indispensable support and infrastructure for the introduction, dissemination and safe use of AVs. The Act of Law has also regulated indispensable requirements concerning the AVs. The Act of Law is to contribute to the improvement of public life and the development of national economy by promoting AVs. Ladies and gentlemen, one would be hard-pressed to show everything that is going on in Poland on a single slide when it comes to AVs, which is why we have decided to discuss the topic during today's conference. We have adopted a strategy of sustainable development in transportation. By 2030, we have also launched a center of competence for connected and autonomous vehicles, but we should also focus on recommendations. Before I begin talking about them, however, let me take a step back and go back to 1968, when a track in Germany saw a spectral car. It was a Mercedes that was to test Continental tires. The human factor was eliminated altogether. The vehicle was fitted with sensors and it cooperated with a wiring system when moving along the track. And it turned out that it was just the beginning. It was the beginning of automation. In 1968, that was a distant future, whereas today we are witness to such changes. I believe that we will be able to meet such and encounter such automated vehicles on Polish roads, but a lot remains to be done. Were we to only limit ourselves to legislation, it is worthwhile remembering that future AV-related legislation will have to be drafted with the global vision and mission in mind. Moreover, we will have to take the perspectives of all regions into account. We have to bear in mind that the international context is hugely varied. International organizations and national governments ought to cooperate and make comprehensive decisions. Moreover, entities focusing on legislation in the area of AVs should pay particular attention to general legislation and legislative frameworks for given areas, and they should also focus on specific technologies and their impact on human rights in order to predict issues which may arise. And last but not least, let me offer a few words of summary. We should definitely ask the following question: when can we expect full transport automation? It goes without saying that the greatest number of supporters claiming that AVs can only be allowed for traffic once they are completely safe is the largest. Now, will they be safe? Time will show. We will indubitably never be 100% certain. Similarly to air transportation, it may turn out that software will be buggy because it will, after all, be human beings programming all AV systems software. We will also need to work on changing mentality. So the generation change will be important as well. Thank you very much. AV Poland 2021 is an interactive conference. We are waiting for our guests to ask questions. We do have such questions. The first question is addressing Sławomir Lewandowski of the transport strategy department from the Ministry of Infrastructure. We were talking about solutions that need to be introduced in order to make AVs part of Polish traffic. Have you planned any specific activities to that end? Yes, our project assumes that we are going to be continuing our works. We have just closed the first stage of the project. Now we are entering the stage of implementing research findings for practical use. Now, from the viewpoint of the Ministry of Infrastructure, we intend to design legislative changes making it possible for AVs to hit Polish roads. We are going to implement those solutions in order to introduce AVs also in hybrid traffic. I believe that over the span of the next year to 18 months, 12 to 18 months, we will be able to take a closer look at overall effects, and we will be able to focus on actual research, and we will be able to start testing AVs to be introduced to Polish roads. We have another question to Professor Iwona Grabarek of the Warsaw University of Technology. Professor, you were talking about the trust placed by drivers to AVs and AV systems. You told us that this trust is dependent on age, gender, and affluence. Will the Warsaw University of Technology embark on research to find how much confidence is placed by drivers in connected and automated vehicles? Yes, indeed, research will be a requirement. Social resistance is very important. Now, as part of the project we are talking about here today, we need to hit the next stage of testing and researching the decision-maker community, not to mention the scientific community. We have to focus on the knowledge and awareness of such transportation and the implementation of certain transport-oriented solutions. People have to understand what kind of solutions we are talking about, what their advantages and disadvantages are, that it is nothing worse than lack of knowledge. Knowledge is a powerful tool. Once you have knowledge, you can resolve any problem. And that is our next challenge. Thank you very much. We also have a question to Professor Andrzej Czerepicki of the Warsaw University of Technology. Professor, you were talking about solutions, making the introduction of certain solutions swifter. So, are we going to be talking are we going to have the LiDAR of the camera as the main solution? We have to use LiDARs and cameras, as has been said before. Obviously, we have been using cameras before. We have had cameras mounted in standard class solutions. Nonetheless, LiDARs have to go through the entire process, of testing and verification. Nonetheless, it is only the integration of data from all sources that will allow us to provide you with a uniform answer. Thank you very much. Well, obviously, we are going to be facing a number of changes in the upcoming future. We will have to face mentality changes in ourselves. We are going to be talking about the topic during this conference. A brief break, following which we are going to organize a panel of experts from the Visegrad Group focusing on the integration of connected and automated vehicles in the V4 country community, so across the Visegrad Group countries.
Miło mi Państwa widzieć.
I am happy to see you after the break during the AV 2021 conference. Now we are going to have an international group. We are going to talk to experts connecting online from Hungary, the Czech Republic, Slovakia and Poland. We have been joined by Adrian Mazur, the director of the transport strategy of the Ministry of Infrastructure. We have Mr. Peter Varga, the Director General of the Section of Road Transport and Land Communication. And we have Mr. Teresa Chichkova of the ITS, Space Activities and Research and Development Department, and Professor Zsolt Szalai, the head of the Automotive Technology Department at the Budapest University of Technology and Economics, and the head, it will be the panel will be moderated by Mr. Zofka. Ms. Zofka, I'm sorry.
My name is Eva Zofka. I'm a transportation expert working currently for the Center of European Transport Projects with many years of experience in transport planning, travel demand, and obviously automation. With this session, I'd like to welcome our panelists from the V4 group, and I would like to ask you the first question in regard of the automation. In response to the growing demand of legal and organizational framework for the road transport automation rollout, EU member states show different approach. The range is from non-binding roadmaps and study documents such as the path to the self-driving future, the document in the Netherlands, throughout the policy documents such as French Strategy for Development of Automated Road Mobility 2020-2022, to the practical documents like the Code of Practice for the Belgium testing. And the question is, could you give us an insight of your country's strategic approach on road transport automation? And the first question goes to Peter.
Thank you. Can you hear me? Just somehow move or... Can you hear me?
Yes, yes, of course. Yes, we hear.
Okay, thank you. First of all, thank you for inviting me, and hello to everybody, to all participants. We have not seen a long time due to this COVID era, so hope this will improve in the coming times. So back to the question. In Slovakia, we are trying to be pragmatic. So if I should choose, we are more towards the French approach. What we did, actually, the good news is right today we had a management committee of the ministry in the morning, and we approved our smart mobility strategy. The smart mobility is a bit wider than only autonomous vehicles or, this topic, but anyway, it sets the base. We have adopted fully the European Commission strategy, and we are developing it in the context of Slovakia. This is, let's say, maybe 1/3 of our project, and let's say we are almost getting close of this 1/3, because we are still pending the government approval, which should happen within, let's say, 1 month. And we will continue by quite pragmatic and practical things. So we are establishing a small unit which will be in charge of supervising all these type of activities. We have started preparation of legislation changes. We started preparing the documents for the next programming period, where we want to allocate some financial resources for connected autonomous driving or smart mobility in general. So this is our approach. We started with strategy, but we are now moving more to practical elements.
Thank you very much for this interesting insight from Slovakia. So, I'd like to ask to receive an answer to the same questions, Teresa.
Good morning, everyone. First of all, I would like to thank you for inviting me to this conference. Pozdrawiam też serdecznie wszystkich uczestników konferencji. Dziękuję za zaproszenie. I'm from the Ministry of Transport, so I would also give you a short overview what we are recently doing and what are our main focus areas, as you asked, to give a closer insight into the strategic approach. I would say that in the past several years, swift of technological development has been characterized this era. Also in the Czech Republic, we decided to follow this trend of, let's say, future mobility and started playing a more active role. Maybe not only because of the automotive industry, which is very strong in the Czech Republic, but also for more broader consequences the automated mobility can bring to the society, better safety, better accessibility. We also quite closely follow the development at the EU level. Recently published EU strategy for sustainable intelligent mobility could serve as a kind of framework for our joint activities in the area of automation, mainly road automation. And so what we are doing in the Czech Republic, at the ministry, we have a team on this topic. So in the past 2 years, we have been developing the area in certain areas. We set general goals and defined these areas in 2017 by approving a strategic document called Vision of Autonomous Mobility Development. It was the first document of such kind, and we focused on several aspects, so technical, infrastructure, legal, and also social, and also research, which is a very important part of the whole development. So this document set the main goals and main aims we would like to reach within next years. Of course, one of the main areas is the legal area and the legal framework. We will be, I think, discussing this also later on. We also focus on public investments into the testing support and RDI support. We, for example, set up a new program for transport applied research. Since 2019, we have a specific program in the Czech Republic being implemented. We are also preparing financial support within the National Recovery Plan for this area. And what is maybe quite important and interesting in this aspect, we established an ethics commission at the Ministry of Transport on the issues related to the automated and autonomous vehicles. The commission is working almost for 1 year, and now we would present the first outcomes and the recommendations that are covering general issues and also technical aspects, research aspects, data aspects. So these are the main areas we are now focusing on, and we will also continue in this effort further on by also preparing a more detailed document, kind of action plan for automated mobility in the very near future.
Thank you very much, Teresa. It's very good to hear that the ministry is really taking these issues very seriously. Now I'd like to ask the same question, Zsolt, please.
Thank you very much. In Hungary, the automotive industry plays a really significant part in the Hungarian economy. So it was a governmental strategic decision to support the future of the automotive industry. And by means of that, Hungary invested 150 million euros in a proving ground, which was initially designed for the connected and automated mobility testing, so the tribe approval. This is called Zala Zone, and it is already open for the testing of these kind of vehicles. Beyond this, so beyond the fences of Zala Zone, Hungary founded the so-called Mobility Platform. This is a governmental supported institution which is dealing with other important questions like education, legislative background, communication, data privacy, type approval testing, and things like that. And within this, Hungarian government has modified the traffic legislations in Hungary in 2017, April. Since then, it is legal to test automated vehicle functions on public roads in Hungary. without any territorial or timing limitation. Beyond that, the construction of the M76 highway in Hungary, a road which will be as smart as technically possible, has already been started. And a certain 12-kilometer long section of this highway can be easily closed and can be part of high-speed tests up to 270 kilometers per hour. And beyond that, I can also announce that in Hungary, the Budapest University of Technology and Economics has worked out a dedicated master course called Autonomous Vehicle Control Engineer. This is a brand new education, just taught in English, and we have our first graduates finished and having their diplomas, and we got really good feedback from the industrial companies. And there are also international and local research programs that I would like also encourage the V4 countries and the V4 countries universities to get in touch with us and incorporate with us to do automated vehicle related research at Zalazon. So finally, I would like to summarize as that the Hungarian government has a quite comprehensive approach with this autonomous future, and I hope we can make an impact on this future. Thank you very much.
Thank you very much for these answers. It seems like it's very important that the academia works closely with the government, and we can totally see it in Hungary as well as the Czech Republic and Slovakia. So all these efforts are really appreciated. And I think with this conference, we also want to kind of start again our cooperation as the V4 group. So I think after the pandemic is, let's say, almost over, I think we need to go back to more close cooperation and start really working not only on the documents and on the strategic level, but also on the practical approach, how to really use it and how to actually take into consideration all the research programs and how to implement it. Okay, so I think we could go to the next question. Could you elaborate a little bit more about the organizational and legal framework related to the automation in your country, presently in place or planned? So I'll ask Teresa to answer this question first.
Oh, thank you very much for the question. Although it's a complex one, and definitely there is no an easy answer to it, because it's a legal environment is one of the most challenging areas, one of the most complex areas. So at least to give you a short hint, what's being prepared nowadays in the Czech Republic, complex analysis is being elaborated. That analysis also includes the recent development at the UNEC level and also EU level. And of course, this analysis tackles mostly the automation from level 3 and higher. Because nowadays in the Czech Republic, the vehicles of SAE level 2 are allowed to be in the real traffic. What is very favorable is the environment for testing in the Czech Republic. The testing operations of vehicles is codified, rules and obligations are clearly set. There can be permission obtained to vehicle or systems and parts of the systems producers. It can be permitted also to technical service. So if the set of rules is followed and all the safety aspects are being in compliance with the rules, the testing of even higher automation levels can be conducted. On a Czech roads, there are several companies that are doing it at the moment, let's say. So we have quite favorable environment in this sense. And we are working further on the, let's say, real traffic environment in the sense of legal framework. As I said, we see as very important also to follow the international/European environment and current discussions and ongoing progress, especially in automated line keeping system, UNEC regulation, as well as the others, and then the implementation at the EU level. this might be one of the areas where the V4 countries could be more closely cooperate, as in the sense of preparations for these of these documents, and also in the sense of their implementation, some best practice sharing and knowledge-based sharing would I think help all of us in this effort. As I said, is one of the most challenging one. So at least very brief description of what is the state of the art at the moment in the Czech Republic regarding legal framework. Thank you.
Thank you very much. Very interesting perspective from the Czech Republic. Now, I'd like to hear how this is done in Slovakia. Peter, please.
Thank you. We have actually engaged in two parallel activities. First of all, what we have decided, and that might be kind of a strategic decision, we are not trying to replicate or to trying to invent something on a long term, because we are really hoping for, and we see that this is going to happen, some harmonized European solution, also on legislation and all the consequences around. So what we have decided was that we will be waiting with the huge legislation changes for Europe, for European Commission solution, but it does not mean we are doing nothing. We are trying to focus now on a short term, let's say low-hanging fruits, which we can do to allow testing, to allow some first pilot operations within our legislation. So we are here trying to be, again, very pragmatic. We are not trying to solve everything right now, and knowing that in a few years there will be harmonized legislation at EU level, but we are trying to somehow cover divide areas which we identified in our legislation. But in parallel, what we also did, because we just do not want to be followers only, so we have run a study which really compared. We have decided to compare like 7-8 countries, some of them comparable to Slovakia, some of them not, but all of them understood to be let's say the leaders in this area, and we are trying to really get inspired, and we are trying to accommodate the best practices which they have implemented and which they work. And this goes to legislation, and this goes also to the organizational stuff. So according to the best practice which is shown in the world, we will be building, which I was referring to in my previous speech, a small unit. We call it the National Coordinator for Smart Mobility. And to put it simple, we want to be kind of a one-stop shopping for the companies, for academy, for whoever who wants to make some pilot testing, who wants to make some R&D in this area. So it does not need to go door by door from one ministry to another ministry and from one office to another office, but we will try to do, let's say, account management for them to make it as smooth, as simple for these subjects as possible. So from legislation perspective, waiting for harmonized approach and doing small changes to allow R&D, to allow piloting, to allow testing, and supporting this testing also organizationally and helping these companies to deal with state, which is not always very easy. So we are trying to improve this.
Okay, thank you very much. I think pragmatic approach is really appreciated here, not to try to solve everything at the same time, do it step by step. So this is a really good experience. Now, I also would like to go back a little bit to the first question, because I'd like to ask how this is done in Poland. You know, it's good to have a strategic approach, but also how to join the strategic with the legal framework, organizational framework. I'd like to ask Mr. Mazur to tell us how this is done in Poland, please.
Thank you. Thank you for this question. Let me start with greetings. Welcome, our dear V4 guests. I'm very happy to have you together with us during today's panel discussion. I still remember our meeting in Bratislava 2 or 3 years ago. That was very productive, and I hope that after the pandemic will be over, we can carry on and meet each other in person. It's just a matter of time. We're going to announce this meeting again, hopefully. But irrespective of the situation, I'm so happy that we can discuss the very up-to-date topics of transport automation together. So firstly, let me start with the strategic approach which is put forward in my country, in Poland. So as you probably know, because it was clearly stated in my presentations, we have one overarching transport strategy of 2019. And then the automation plays a key role in the document. It's reflected in one of the direction of intervention devoted to the organizational structure of road transport, and we are very much putting a lot of attention to that, even to the level which was not, let's say, seen so far, because among 22 strategic projects, one is devoted to road transport automation, and this is also the substance of today's conference. I mean, the information on the status quo of the project so far is also presented today and tomorrow. So it's good to have this opportunity to share with you guys our approach. So strategic framework is simple. First, the transport development strategy till 2030, the general objectives, very broad ones. And then under the projects we are implementing at the moment, we are elaborating a roadmap, which will be there hopefully within a couple months, and it's going to be the outcome of the project. So as you can see, we have one strategic document, which will be assisted with very operational one, including interventions, deadlines, and key elements of intervention under the automation of transport in Poland. Getting back to structures, today we have launched a competence center, so connected and autonomous mobility, and I do believe it's going to be a very important element of every discussion concerning CCAM in Poland in next months and years, because we would like to see this very much actively involved in all the processes at the EU level, also at the UN level. So we do believe that the Motor Transport Institute, who was given this task, will be the best place to accommodate all of those activities together and to pull the strings, to be frank with you, in terms of road automation in our country. The second question concerns the legal framework, and obviously I'm very familiar with Peter's Varga approach that we are not planning to reinvent the wheel in our country, but a couple years ago we introduced legal changes under the Act on Electromobility, where we allowed the testing on public roads, obviously under certain legal regime. Under the project, as I said, which we are currently implementing, we also plan to amend those provisions. And I think that till March next year, we're going to be ready to present a clear proposals how the legal testing should be amended in Poland, because we know that there are some needs in order to supplement the presently existing legislation in that respect. Structures, as I said, Motor Transport Institute. Within the ministry, we have dedicated units responsible for innovative and sustainable mobility, plus obviously very supportive role of our road administration, which is installing at the moment CITS stations around Warsaw on the road network, plus Road Transport Inspectorate, who should be responsible for overseeing and checking the enforcement of the provisions concerning connected and automated mobility in Poland. Thank you.
Thank you very much, Adrian. This is indeed a very good news that today was launched the first day of the new competence center that was started by the ministry and the Institute of Motor Vehicles. I think it's a very good news for Poland and for us as the V4 group, so we can really start this cooperation in not only a legal framework, but also joining with many experts who have good knowledge about how to develop and how to implement automation in our part of Europe. So, Zsolt, please tell us how the legal framework is working in Hungary, what you guys doing to help us implement automation in your country.
Thank you very much. I strongly believe that legislation and regulation can be one side a barrier, but on the other side an enabler. So this is really important to address these issues. And as I said, in Hungary since 2017, so since 4 years, it is legal to test automated vehicle functions on public roads. There is a certain procedure that a company has to carry out, and this concerns the company's quality assurance procedures. This concerns obviously the vehicle that will be tested on public roads, so it has to be prior proven to be safe in a closed area, in a proving ground. And of course, the test personnel has also certain requirements. But once this is fulfilled and certified, an automotive developer company can get a license, and with that license, with that permit, they can use all Hungarian public roads anytime they want for automated vehicle testing. So this is functioning without any issues up to now, and we are moving towards the safe operation of these vehicles to find the background. As my colleague said from the other countries, we are also participating and trying to formulate the UN EC level legislation formulations and also the European Commission level legislations. And we are also negotiating with our neighbors, for example, on the potential mutual acceptance of these member state licenses for testing. And I can tell you this is not an easy task to carry out a mutually accepted license. So for this reason, I really promote cooperation and the European legislation to come out so that it provides an umbrella, a European framework for this issue in the future. Thank you.
Okay, thank you very much. So we've heard about the strategic country level approach in our countries. We also talk about the legal and organizational framework, which we now all know is important. So now let's quickly talk about the biggest challenges in road automation in the next 3 to 5 years in your countries, and then we can talk about the cooperation in the V4 group. Please, Teresa.
Yeah, thank you very much for the question. Although, again, a little bit tricky one because the challenges, there are quite a lot of challenges. We have been speaking about legal framework and legal aspects, so I would not repeat myself and as well as my colleagues in this. Definitely, solve the legal framework is necessary also for the safe introduction of the vehicles and also for rising the social acceptance, which I see as one of the challenges, maybe one of the biggest challenges, because without the social acceptance of technologies, none of the kind of breakthrough technologies such as automated driving can be implemented and used. There have been several research studies already conducted, and we see a rather careful approach of the public, especially when kind of negative news is on air or in the newspapers. So we see this as one of the most important areas. It's also one of the reasons why you have this ethics commission established. I also see one of the challenges lying in the cybersecurity. Vehicles will definitely produce large amount of data. There is communication between vehicles, there is communication between vehicles and infrastructure. So the cybersecurity is one of the top priorities also for the RDI and for the projects that we are also supporting within our financial frameworks. And this is something we also quite strongly put emphasis on. And maybe not a challenge, but rather an opportunity is the boost of the innovation system, the support of small companies, startups, new ideas. This is something we should consider maybe not as a challenge, but something we should focus on as well. Therefore, we are together with some other organizations establishing a Mobility Innovation Hub. It will start its operation in July, and we would like to a little bit speed up the process of getting to some new ideas and new solutions, and to also include the automated mobility into the broader system of mobility, into the mobility as a service concept as well. And this is something we should also think of when we are setting out the strategies, that how these technologies will be in the practice really used, and how the public will gain all the positive out of it, because definitely there are many positives, but there is a long way, let's say, to get the most out of the technology, which is already, I would say, developed to some a very high level and almost ready for being put into the real traffic. But how we take this positives out of it, this is one of the challenges we are facing at the moment.
Thank you very much. Splendid. So I've heard the cybersecurity and public acceptance seems to be the biggest issues and challenges right now. Anything else, Peter?
Well, I would probably underline everything what Teresa said, and just maybe put it by one word: it's a complexity. So the complexity of the problem is really the challenge, because we are touching everything everywhere, just to put it simple. But I would add one more thing, and it's we are trying to anticipate many things, and which are not really there happening on the market. Some of them are, but some not. And for example, my experience each time when I speak on the conferences like this, or whenever I speak to private sector, I'm calling them, come ask me, bring the topics, because when I'm trying to invent the solutions for the problems which were not described properly, I might be completely wrong. And we do not have really many questions, and we do not have really many initiatives, at least in Slovakia, but well, I would be expecting a bit more really. So we are also trying somehow to mobilize our partners in the market, and we are establishing the. It was mentioned already in Hungary, the mobility platform. We call it the platform for intelligent mobility. So where we are putting all the actors around the table, and we really would like them to bring real practical questions, real issues to solve, because this will be the proof for the solutions which we are trying to design. This will be the proof that the legislative changes we are doing are the right ones, because they are responding to the needs, that we are not just inventing some legislation changes because we believe or we hope something is going to happen. So for me, the one big challenge is the complexity, and the second big challenge is really to get all actors properly moving and being demanding. On one hand, it makes my life a bit more difficult because there are a lot of people asking something, but on the other side, this is really showing that that what is really required, what is necessary, and what needs to be answered.
Okay, thank you very much. Definitely complexity. This is very important to understand all the pluses and minuses, and obviously have the right actors around the table to start the communication and cooperation. Obviously, understanding and take up from the society that really automation is safe is really important. Now, I'd like to ask Adrian, what is your opinion about the biggest challenges within the next 3 to 5 years in Poland, please?
Thank you for this question. I would rather refer to objective rather than challenge, at least in one example, because I would also refer to what Peter has just said, because what we need structures. It was also what Minister said in the opening speech. We were lacking structures, we were lacking cooperation, and we would like to enhance this cooperation formula in coming months and weeks. And this is very important because indeed we need effective cooperation formula among private, public sector, plus academia and scholars, because only when we will be joined together, then we can get the expected outcome. So this is very important, and I would like to see in Poland the fully fledged ecosystem of connected and automated mobility within a couple months. Because there is very needed in terms of any in-depth discussions, in terms of encouraging all the partners and actors to be a part of the process in my country. Getting back to the challenge, which is a very, I would say, time and intellectually challenging as well from my side, is the issue of mixed traffic. I was referring to that also in my presentation. And we can expect that within a couple weeks, months, depends on the speed of the legal processes in Germany, we would have a country which allows SAE level 4 vehicles on the roads. And obviously our drivers, the Polish citizens, should be prepared for that, should be somehow, let's say, getting used to the situation where we can see a driverless car overtaking us on the road. So this is very important, this is very new, at least for some of the commuters, some for the drivers in Poland. So this is very important to, let's say, prepare framework in order to allow effective cooperation between conventional vehicles and autonomous vehicles in mixed traffic procedures. What is also very important is the role of the public administration and the role of the public transport as such, because I can imagine myself the situation where the front runner in AV in Poland would be the public transport, for example, which can be put into operation in separate lanes on the separated pieces of infrastructure, which makes things much more easier in order to operate AV on Polish, for example, road system. So this is also something which we have to work on within next months under the project. So I don't want to duplicate the challenges which were raised by the colleagues from V4 countries, but as I said, for me, first is the structure, which should be operational and working well, and then obviously the issue of mixed traffic and the role of public transport and public administration as well. Because, for example, once we are preparing regulations, the legislation, it's, let's say, outdated from the very beginning of the process, because the connected and automated driving implementation is so dynamic that we'll never be in the position to have up-to-date legal provisions which will be meeting all the requirements and the challenging faced by the automotive sector. Thank you.
Thank you very much. Thank you very much for that. And I've heard one word that was coming in and out, which is the ecosystem. So I guess what you all said is very important to work or swim in sync, as they said in swimming. So synchronized swimming, or in our automation word, cooperation, stakeholder outreach, and then the good legal framework and strategy is very important. So I'd like to ask Zsolt to answer this question about the biggest challenges, in your opinion, in the next 3 to 5 years. Please.
Thank you. It is really good to be the last in the position to answer the questions, because I can refer back to all my colleagues' messages. And I fully agree with them. I just can add that maybe the common denominator that they raise the issue can be reached through a thorough prior testing of the systems before they go out into operation. And what I see is that due to the complexity mentioned of those systems, we have an approach where safety and security is tested in combination, so we do not separate safety and security testing. And what we also see is that due to the complexity of those testing requirements, there will be a strong contribution of simulation within the testing. There will be also a strong contribution of the proving ground or track testing. And also there will be a very strong contribution of public road testing, because of the uncountable potential scenarios that can happen on public roads. So these all together, if we together create a safe ecosystem for that, I think we can prevent the disadvantages mostly mentioned, the potential distraction of public acceptance due to the very big competition on the market, which makes companies believe that the sooner they provide their solution on the market, they will have a better position. But on the other hand, we also see that those systems are not, in some cases, not safe enough to go on public roads, and we have to be together very careful on that. What we allow to travel on public road, it must be safe enough to enable them to go on public road. And I think this could be our common value as V4 to the European other countries. Thank you.
Thank you so much, Zsolt. Yes, this is all important. Out of your last answer, testing seems to be the most important, and the requirements and specification for the testing, so we know how to do it safely, so we can perform it in the organized and controlled manner. This is definitely a very important outcome of your answer. So now, going down to the last question, we've heard all the challenges, all the benefits, strategic approach, legal framework, and the biggest consideration for the next 3 to 5 years. Now, how can we really implement it? How can we improve our cooperation? What should we do so we can really cooperate on the road transport automation within the V4 group? So I'd like Adrian to answer this question, please.
Thank you for this question. So what I have said in my previous contribution, I'm so sorry that we cannot continue the formula of meetings concerning the connected and automated driving. And I do believe that it's just a matter of time we're going to relaunch this way of cooperating together under the V4 umbrella. So I do believe that this, let's say, very in-depth, very active meetings will be continued in coming months. What is also very important from my viewpoint is the fact that we should somehow elaborate a common framework for testing, because we are talking a lot about the strategies, organizational structures, but what we need is the practical cross-border test. And I would like to see also our competence center, which is pretty new, launched today, to be involved in this process in the future, because it will prove that the cooperation under V4 group in terms of the connected and automated driving is effective and it works. So this would be my first suggestion. Then obviously I think that we should think together and work together with all the colleagues from Slovakia, Czech Republic and Hungary to have a common project, common research or implementation project concerning the connected automated driving. There is a number of opportunities which are raised at the moment from the EU funds as well, because the new financial perspective is underway. We are also programming these documents for the new EU financial perspective, where we see also the role of the automation of intelligent transport systems. So I would imagine myself a very robust cooperation in this area to have a V4 joint undertaking, joint project, which will deliver in the end at least the legal framework for testing and maybe test itself on the cross-border dimension as well. So that would be my suggestion, and I'm looking forward for next meeting in person. And taking this opportunity, I would like to thank you guys for very active, even though the pandemic broke out, cooperation during Polish presidency of the V4 group. And we're going to have a ministerial conference soon, which will be the crowning up of the Polish presidency. And I hope that today's meeting is also a very important step in order to enhance our cooperation in Visegrad Group countries. Thank you.
Thank you very much, Adrian. Once again, congratulations to all to the new competence center, and hopefully this will be a really good opportunity for all of you to cooperate on this important issue. So now, Teresa, would you agree with Adrian, and what should be the most important focus areas regarding the cooperation within the group? Please.
Definitely. Thank you, Adrian, for mentioning RDI and RDI projects as one of the most, let's say, prospective areas that we could cooperate even closer that are cooperating at the moment, because research and testing, and especially cross-border testing, is one of the also the priorities at the European level, is being supported within also some European programs. So definitely there is also a funding related to these projects, as these projects can be initiated by all our countries, all V4 countries. I see a lot of value added in cross-border testing, not only maybe testing of some technologies, but as you said, also focusing on some legal aspects or testing aspects in the sense of standardization or harmonization. These areas are definitely also the areas that we would be very interested in. We have already initiated some minor activities in this area. Definitely more strategic approach to this will be very welcomed. As I said, research and development is now one of the pillars of the future autonomous mobility development, because still we are in the phase, in some aspects, in the phase of research in some aspects. So definitely this is one of the topics. The second one, I think I've already mentioned, this is the best practice sharing, not only within the policy making process and strategy setting, but also in the sense of some common approach to the most challenging issues, common approach, let's say, to the initiatives being set up at the EU level. This is something we should definitely discuss further on within this framework. And we see a lot of value added. And also thank you also for raising, in fact, this roundtable or this discussion in this format. And definitely we are ready to continue in this joint effort. We have a lot in common, both challenges, opportunities, and we can definitely learn from each other in many aspects. So thank you for raising this, and we are definitely ready for even closer cooperation with you.
Thank you very much, and for your readiness to cooperate with us. Now, so I'd like to ask Zsolt, so you won't be speaking last today. Also, could you also emphasize a little bit more on the cross-border testing, since you guys have an experience with the Zalazone test site, please?
Thank you very much. I also would like to take the opportunity to thank you very much for organizing this V4 discussion forum between us, or among us. And what I wrote down as primary suggestion for the future is to really create such formal forums for information exchange and to share the good practices with each other. As you mentioned, this kind of cross-border testing, I think this could be a proposal where our V4 countries could create a harmonized proposal on an EU level, and also access to special funding by means of creating a corridor that connects our countries together in a manner that automated vehicles can also travel without any problems on that. And to encourage our effective and practical proposal, I have a special offer now to V4 countries, researchers and universities. Since our university, BME, has a funded scheme so that we can access Zalazone Proving Ground and we can finance our researches there, I would like to offer here to V4 universities and V4 research institutes the cooperation with us. And within this cooperation framework, we could create a joint research or collaborative research. And through this, we would take care of the costs of Zalazone, and our partners from any V4 countries could participate and create a joint measurement series or whatsoever. The only thing is that we should create a joint scientific publication as an outcome. But as I said, on our side, we would take care of the costs of Zalazone, and I would like to invite every V4 country researchers to take part and to create and initiate a joint and collaborative research with us there. Thank you very much.
Thank you very much, Zsolt. Thank you for this genuine offer of cooperation. I think this is a great opportunity for all the countries, so we can sit down on the results and actually look at the practical application of automated vehicles. As you mentioned, the only thing would be a publication, which I think is really something that everybody is looking forward to, and it shouldn't be a big problem. So I think everybody would be interested in doing so. So now the last person in our panel is Peter. So please, you can sum up. You've heard what others said, and would you like to add anything else to this cooperation within the group V4 in terms of automation? Please.
Thank you very much. I was really wondering if it is good to be the last one after the speeches like this one. I definitely do not have such a vibrant message as a colleague from Hungary, but if you ask me to sum up, I think, and this is what I would say anyway, I think the message which was said by everybody is the information sharing, best practice sharing, information sharing, because We need to achieve efficiency. It does not make sense to test the same thing in Czech Republic, in Slovakia, in Poland, in Hungary, in Austria, Belgium, I don't know, everywhere in the Europe. So we should really cooperate and coordinate to avoid duplicities, to avoid inefficiency, and vice versa, to really share the knowledge, share the information, share best practice. The most of this topic is really global. The only local physical thing is the infrastructure, but all the rest is really globalized. So there is no reason to have like very focused local country-dependent approach. But the more we harmonize, the more we coordinate, the faster, the better result, I believe.
Thank you very much for this great summary. I think we've come up to the end of our panel discussion. I'd like to thank you very much for your time and for your genuine contribution, and obviously for the further offer of cooperation and for the announcement of the new competence center. Any last words from anyone? Adrian, anybody wants to emphasize anything else?
Yeah, it's maybe just 2 words to wrap up the discussion. I think that we should also somehow elaborate the possibilities of financing under the Visegrad Fund, because it's working, it's there. So maybe it will be good to check what it's available, and if possible to have a common application form, at least from the beginning for something small, and then in order to speed up the process, roll out CAD in V4 countries, then we can try to find together any other financing solutions at the EU level. And according to the generous offer from our Hungarian friends, obviously we're going to send this message to our universities, technical universities, to academia, because in fact this is a very very much R&D oriented conference today as well. So I think that it's very good to hear that when we have such an audience listening to our conversations today. So thank you for that. And what I can guarantee that we'll be in touch. We'll somehow summarize this panel discussion today, draw some conclusion, and send you guys in order to find a common ground for further cooperation.
Thank you very much.
Okay, thank you very much. Have a good day, and we'll be in touch with you very soon. Take care.
Thank you very much.
Bye.
Bye-bye.
Thank you. Goodbye.
Bye-bye.
Thank you very much for being with us. It was our first session today in English during AV Poland 2021. The second is still ahead us, but after a break. A jeśli już tutaj przerwie mowa, no to właśnie...
Since we're talking about the break, the next panel is going to be chaired in Polish and is going to be on technology changes in the transport sector and challenges that are related to them. Just to remind you, you can ask questions of the speakers, also the ones that spoke in the previous sessions. You can use the chat function and you'll receive answers later. And I'll see you later at the next session of this conference. Thank you.
Dzień dobry, mam przyjemność powitać.
Good afternoon. It's a pleasure to welcome you after the break for our next panel session at the AAV Poland 2021 conference. This is a session with guests who are present here in the studio. People say that change is the only constant in life, and the same pertains to transport. And the change is there because hopefully in several dozen years we'll be able to travel with automated or autonomous vehicles, and that's why these changes are needed. So this is the topic of the next panel, the role of mobility in the future and the role of the human in the mobility of the future. And this is going to be chaired by Professor Świderski.
Dzień dobry.
Good afternoon. My name is Andrzej Świderski, and I have the pleasure of chairing this panel. As we heard, we are going to be talking about technology changes in transport and challenges that relate to it. There are many such challenges. Some of them have been mentioned in the previous sessions. The challenges include technology, but also ethics, psychology, management, organization, and law. Let me now present our experts. Introducing Professor Marcin Ślęzak, Director at the Motor Transport Institute. Dr. Michał Niezgoda, President of the Board at Robotech AI. Professor Iwona Grabarek, Head of the Transport Faculty at the Warsaw University of Technology, and Professor Adam Tarnowski, Psychology Institute at the Copernicus University in Toruń. We'll start by a presentation by Dr. Niezgoda about current technology trends in monitoring the passenger and the driver and the passengers. Right, I would like to start by presenting some trends in monitoring drivers and passengers. I've got some materials and slides prepared about the current technology trends. Before I move on to the presentation, we are not nearly as well-known institution as the ITS, for example. So let me introduce the company. We support car manufacturers as far as software is concerned, and the software we deliver is, among others, related to driver and passenger monitoring systems. In addition to software, we are also developing systems for automated and autonomous vehicles using artificial intelligence, machine learning, and other techniques and technologies that are supposed to help these driver assistance and autonomy systems. We're also part of a larger project to automate transport. This is called the AutoWare Foundation. You can see some of the names of the participants in the foundation who are working on software to be made available to R&D and academic institutions and other stakeholders that would like to test the software and possibly implement it in vehicles. Now, today I would like to talk about monitoring systems. They are called different brand names: DMS, DDAW, EMS. Now, DMS stands for Driver Monitoring System. Then we've got Driver Drowsiness Attention Warning, and Interior Monitoring System. That's IMS. And when talking about monitoring the driver, we should really talk about DMS or DDAW. That's the naming promoted by the European Commission. Now, these systems are there to detect any state or condition of the driver that suggests tiredness or drowsiness. They can also detect whether, for example, the driver has been using the multimedia system for too long, or maybe he or she is texting on the mobile phone. And in the future, it will be able to detect driving under the influence of psychoactive substances, or perhaps passing out as a result of, for example, a heart attack. And then we have the IMS systems, and these are used to monitor the interior of the car. And they should be, they're mostly used to, for example, inform the driver that he or she forgot to take their baby out of the car. Now, this might not be a very common occurrence, but it could end in tragedy, especially on a very hot day like today. So this is something that reminds the driver to do it. The IMS system would also let us know, or it would inform the car about how many passengers there are inside, whether they are seated in a safe position. And there are IMS systems that monitor the seat belts. For example, some drivers fasten the seat belts behind them, which does not contribute to safer travel, and potentially detecting other objects in the car that might constitute danger if a collision occurs. So these are driver monitoring systems and passenger monitoring systems. Now the question is, how do these systems relate to automation of transport, which is the topic of the conference? Well, they are very much pertinent. There are more and more situations when, for example, a Tesla driver will activate the second level autopilot that accelerates, brakes, and maintains the position in the lane, but that system does not guarantee safety. It has to be monitored by the driver. And we might assume that the driver should be aware of the fact that they have to monitor the system for their own safety, because it's still the driver who's responsible and liable should an accident happen. But there are situations, and we see videos on YouTube and TikTok with a very popular idea is, for example, they film themselves driving along a motorway in a Tesla while they're asleep and the car is driving itself. Now, this is very dangerous and we do not recommend doing that, but you know, people do that to get more followers on social media, albeit it's extremely irrational and unwise. So in these level 2 or level 3 systems, it has been proposed that safety should be monitored by monitoring the driver. So once we activate the driver assist system, there should also be a monitoring system to make sure that the driver is in the seat, that they are observing, that they're watching the road, and that they are ready to take over control if need be. And that's why many regulators have started working on making sure that driver monitoring systems are installed as an obligatory component in any vehicle with level 2 or level 3 driver assistance system. As a result, when the driver chooses for the car to take over control, the driver is being monitored and their attention is being managed using visual and sound systems to warn them that perhaps they are not being safe and that the car cannot always control every situation, that the driver's attention is needed. Most car manufacturers accept a certain safety buffer, so to say. There's the attention buffer concept in psychology, whereby if a driver cannot if the driver loses their situation awareness by looking elsewhere for more than 2 seconds, well, in order to regain situation awareness, they have to then keep watching the road again for 2 seconds at least.
It goes without saying that the concept will not do away with all distraction or attention deficit circumstances. We are ourselves aware how many situations we do not notice ourselves. Sometimes we do keep our eyes on the road, but we talk on our mobiles at the same time, which definitely translates into an information overload, hugely detrimental to the process of driving the car. Obviously, we could introduce, well, the system would monitor the driver to find out whether he or she is keeping his or her eyes away from the road for more than 2 seconds. And there would be a system to prompt the driver to keep his or her eyes on the road and improve his or her attention span. The European Union is most certainly a leader in terms of introducing driver monitoring systems. We know that all newly manufactured vehicles will be fitted with driver monitoring systems. 2024 and 2026 will be the 2 watersheds, respectively. In 2019, the General Safety Regulation outlines were introduced to introduce an obligation of fitting all new vehicles with such systems. Most recently, technical regulations specifying requirements have been introduced as well. The European Union apart, the United States have also shown an interest in such systems. The US Congress passed the so-called Safety Act, and indeed there is an option of mounting such systems on vehicles manufactured in the States as well. Now, in terms of technological trends, in terms of the design of such systems, there are 2 fundamental sensor groups. On the one hand, we have the visual systems. These systems are based on infrared cameras or traditional RGB cameras, and their purpose is to watch the driver and watch the interior of the vehicle and use specific algorithms to determine whether the driver is tired and or potentially sleepy. And visual systems apart, we also have the driving style sensors to find out whether, for example, the driver is keeping within his or her design lane, or whether he or she is not making sudden moves with the steering wheel, swerving violently, for example. All this may prove or answer the question whether the driver is not tired. All post-2010 manufactured vehicles have been fitted with fatigue metering or measurement systems. We also have the systems monitoring the driver's heartbeat, not to mention other sensors mounted on the steering wheel directly. Such sensors are still undergoing research and development. Now, most commonly, systems will base on visual aids. We are going to have cameras mounted on the steering column. Now, how do these sensors work? Well, the camera monitors the driver, identifying the facial area and the eyes, and uses the infrared monitor display to determine where what the driver is looking at. Moreover, the camera would also monitor the driver's head position in order to determine whether the driver is looking at the road or in the rear view mirror, or possibly checking the smartphone. There are other algorithms to monitor the eyelid position. For example, we take 2-3 second samples to determine the eyelid position in order to determine the fatigue level in a driver. We also have certain algorithms to meter the driver's emotional state. I would like to close my presentation with something that we might refer to as a challenge for the entire automotive industry. The challenge involves the fact that it is very, very difficult to actually identify fatigue in a driver. Obviously, some people show fatigue by closing our eyes, but approximately 20% of all drivers, of all individuals, do not close their eyes when tired. Now, during the COVID pandemic, we were all using face masks, and face masks, as we all know, generate problems for cameras. Facial masks and filtered eyeglasses make it very difficult for cameras to identify the correct, the actual condition of the driver. And that is all from me in a nutshell. Thank you very much. I am sorry, I cannot hear the speaker. Interpreting shall be resumed once I can hear the speaker.
Panie doktorze, dziękuję.
Doctor, thank you very much for this fascinating presentation. I must say that it was a great pleasure for me to listen to this presentation. I found it greatly interesting. It's also wonderful food for thought. So let's talk. Let's kick our discussion off with technical issues. What kind of active and passive systems will be introduced in the nearest future for the automotive industry? And will these requirements be obligatory? I am addressing Professor Ślęzak with this question. Ladies and gentlemen, it goes without saying that state-of-the-art vehicles are fitted with active and passive systems. I don't think that we can expect any kind of major change in the passive systems. Now, in terms of active systems, yes, a number of changes have already been made to legislation, among others by mid-2021. We are going to be introducing driving assistance methods to eliminate certain human factors. We are very much aware that the vast majority of accidents are caused by human beings. The European Union concluded that assisting drivers will definitely contribute to improved road traffic safety. I am probably not going to mention all factors at hand here, but yes, we have the vehicle speed assistance system, a system monitoring the allowable speed of the vehicle and its driver without interfering. The system would simply inform the driver that the allowable speed limit has been exceeded, for example, by impulses to the accelerator. Moreover, other systems can support or augment the braking system from the moment of a hazard occurring to the moment of the vehicle coming to a complete stop. Moreover, braking lights could also be used in a pulsating mode to inform the driver what is going on with the vehicle. Certain systems are already obligatory. For example, the reverse sensors or the stop sensors. There are also the lane departure warning systems. They have already been introduced in vehicle manufacturing. Moreover, we are going to be introducing systems to monitor potential driving fatigue, whereas other systems will monitor the overall driving style of the driver, how often the driver approaches the edge of the lane, and how often he or she makes corrections to the overall driving track or lane. Moreover, certain systems will monitor the driver's eyesight. Actually, we have found that up to 10% of road traffic accidents may actually be caused by driver fatigue. Not to mention the fact that if you exceed the allowable driving time, that generates two effects. We want to go on driving to get to our destination as soon as possible, but secondly, the overall effect is that of driving under intoxication, while intoxicated. Black box systems will also be mounted on vehicles. They have been mounted to a certain extent already to find out, in case of an accident, whether the driver had been using the seat belt and so on and so forth. Given cybersecurity and given the personal data protection standards, such data would not be gathered throughout the lifetime of a vehicle, but only 10 seconds for the period of 10 seconds preceding a collision or accident and 10 seconds after. Well, I don't think that should come as any surprise. We have found that state-of-the-art vehicles, or subsequent generations of state-of-the-art vehicles, are fitted with ever more modern driver assistance solutions. We are following the we are following the 5 stages devised by the American Engineering Association, from a fully human-driven car to a fully automated car. The purpose of all these systems is to eliminate the human error factor and eliminate human beings as the weakest link. And this brings me back to the beginning of my question. Possibly, some of the passive safety components can be abandoned. If the number of accidents drops, we will not require material and energy consuming solutions. Ultimately, the number of vehicles may drop in general, may decrease in general. Electric vehicles will definitely be a contributing factor. Thank you very much, Professor, for that intervention. I do believe that this topic could go on forever. But now let me move to yet another topic, to my next subject. I think that the human factor is of huge importance to transport automation. Now, my first question goes to Professor Iwona Grabarek. Professor, in the course of your intervention during the previous session, you mentioned the man-to-machine interface systems. I would like to ask, why are these interfaces so important from the viewpoint of driving safety? Do you think that any attempts have been made to standardize these interfaces in any way? Indeed, the man-to-machine interface remains an indispensable point of contact between the man and the machine, man and car in this particular case. Once full autonomy kicks in, the interface, we are going to be using the interface just to tell the car where we want to go. But under conditions of partial automation, what we need is a correct and swift contact between man and vehicle. At the current L3 level we are considering, there is an option of handing controls over to the machine. Nonetheless, should conditions be unfavorable and should the should the system decide that it cannot control the car, control should be handed back over to the driver. Which ultimately means that the system has to be very, very precise. All mechanisms have to be hugely intuitive, and information, a sufficient volume of information has to be transferred in order to make the communication scheme operational. Standardization is hugely important. Let us take a closer look at other industries, the airline industry or rail transportation. Efforts have already been made in both these industries to evolve, to develop man-to-machine interfaces. And once all such solutions are standardized and uniformed, operating a vehicle will not give rise to any issues. This is something that the airline industry has pointed to. We have to definitely understand that in the future, people will not necessarily want to buy such a car. Sometimes you will prefer to rent one. We cannot imagine a situation whereby we would be renting one car after another and the onboard computer two-man interface would be different in each and every vehicle rented. Ultimately, we will need to base all decisions on detailed research in order to make the interface as safe and secure as possible. I hope that is sufficient. If not, I can go on. Okay, do we have any questions from our conference participants? Not yet. But now let us remain with the role of the human being in the road transport automation. I would like to ask Professor Adam Tarnowski, how will men change when affected by the automation of the automotive industry? Do you think that driving license exams will change? Now, this is a very important issue when it comes to driving tests, driving exams. Whenever you introduce a new system, you need a new training system. For example, people who are using parking sensors on a daily basis have a problem with parking all on their own. Scientific research has proven, and I don't think we need to have that confirmed, that the more frequently we use support systems, the worse we become at handling specific tasks. So possibly we should simply fit all cars with specific sensors, but obviously sensors differ. Sensors vary. Some react to lane departure. Others react to the central line driven across every lane. But we also have to understand that people change their habits and the way they function. For example, people who are addicted to nav systems have actually had their brain structure changed. It turns out that their brains start operating differently. Their orientation in space is degraded. It turned out that when it came to hippocampal research, that London taxi drivers were really very good at orientation in space, but the hippocampus is not the only area of the brain that we have to focus on. We have to understand that the map is one thing, but the command sequence orientation is a totally different kettle of fish. So this is an issue that we will have to understand. I think that the trainers and examiners will have an ever greater problem with getting people trained, licensed and examined.
Also, like you said, there is no standardization. When a pilot switches to a new plane, they have to be retrained to this new type of plane. A driver cannot be limited just to a single type of a car. So this remains an open-ended situation, so to say, and we are probably going to see a lot of interesting developments. Thank you. I can see we have a question from the participants. And the question is, environmental pollution generated by transport is an important consideration. Will autonomous vehicles solve this problem, especially in large cities? Well, that's a good question. We will certainly change the way we use cars. Smog is generated by the vehicles that drive rather than those that are standing, of course. So in this respect, an autonomous vehicle driving causes the same sort of pollution as a driver-driven car. But what we need to look at is traffic management. In my opinion, the best autonomous transport is public transport. If we have good public transport, we have less pollution. An autonomous car could drive us to work, drive our children to school, and then go back home. But the congestion is still the same because the car is still there. So it's all about changing the mindset and switching to public transport. Only that can reduce pollution. Remember that autonomous vehicles can be petrol or diesel. They don't need to be electric vehicles. And also data collection is at stake. A vehicle like that can collect several terabytes of data on the routes taken, and that means good onboard computers are needed. The computers need energy, and energy has to come from a source. So this is not a simple problem. Environmental protection might be helped, but if we introduce these things in a responsible way, and if we manage transport, especially for the whole city, that would help the most. Thank you so much for the questions from the participants. Let me try a different topic. Some time ago, a robo-taxi was suggested as an idea. Is this continued? Is there any work being done on that, and can we expect these cars to appear on our roads? I'm afraid I don't know the answer to this question. We had this period of excitement with autonomous vehicles between 2012 and 17 or 18. I remember heads of different corporations, including Elon Musk of Tesla, who was saying that in 2019 or 20 we'll have fully automated Teslas and the robo-taxis. Life has shown that this isn't so easy. Waymo, that belongs to Google, introduced this solution in Phoenix, Arizona, and these cars work. They drive the residents to different places, but this is just in a select area. This isn't available anywhere. You know, you can't pick that car up and put it here in Warsaw and hope for it to be able to drive around. It would find that difficult. So these are selective implementations in very strictly defined areas. So before we come up with a universal robo-taxi, 15 or 20 years must elapse, and these taxis will have to be trained to work in larger and larger cities. And what we need is data. We don't have enough data. We're talking about millions of kilometers of real driving and simulated driving. This is something that Google is working on, but what we'll need is billions of kilometers worth of data, I suppose, in order to be able to come up with a car that drives around safely and better than not just an average driver, but better than a good driver. What's happening these days is what we call level 4. These are autonomous vehicles operating in a restricted area. So theoretically, the car doesn't need to be supervised by a driver, but this is used for lorries in mines or some special machines on construction site sections, transshipment ports or airports perhaps. These are the sort of places where the actual reward for this implementation translates into tangible money for the business. Now, the problem with autonomous transport is that that's very expensive. It is getting cheaper, but it's not cheap. And at the end of the day, there has to be a business case showing that a company can generate a profit from implementing this solution. Now, robo-taxi is not something that anyone has been able to develop a good business case with so far. Singapore is a good example. A taxi management system has been introduced there. There's a selected area of the city where those taxis are used, and I suppose they have more experience. I think it's still in an R&D phase. And I'm also not sure if it's completely driverless, without anybody to supervise it. That's what Google is doing. There is no driver inside. But yes, you're right that Singapore is developing very rapidly in this respect. There have been some attempts here in Poland, in the city of Gdańsk, as part of the European Swive program. A car was presented that could be used to drive around in the vicinity of the Gdańsk Zoo, but it was just a selected stretch of the road. It was just more of a technology demonstrator than a proper car that can regularly transport people. I've had the opportunity to get a ride in this car. It's quite an interesting feeling to be on board. And what's interesting is that these vehicles are assertive, I should say, in how they drive around, which makes the passenger worry that an unusual situation might happen. If there are no comments, let me now give you the next question from the participants. Some people worry that implementing these vehicles will negatively impact the market of professional drivers. Will these smart cars take work away from people? Yes, and we are talking about it in our circles. It seems that automation of any sort, any automation brings about some threats with it. Now, this is a very remote prospect. It's not going to happen that soon. And building the infrastructure needed by autonomous vehicles, that will also require people to do it. And it's not just very high competence jobs, but also lower skill. Now, certainly, you can't expect a 50-year-old truck driver to suddenly learn that overnight he or she has to become a software developer. But, you know, this is the case with every technology. Technology starts working on behalf of people. For example, these days there are huge warehouses that only employ a handful of people and the rest is automated. The same will happen with transport. Now, an additional problem will be that we'll have a host of people who are very competent in their work, but it'll be difficult to offer anything else to them. According to statistics, people are saying that it'll be good for long-haul transport because there are not enough drivers to go around for those long-haul lorries. So if platooning is used, for example, then we can carry more goods, and it has been calculated how long a driver can drive during a week and how long the autonomous car can drive. But if, as it is the case now, logistics companies are short of drivers, then automation is a good way forward. But like you said, it's difficult to say how to retrain, especially that after you've reached a certain age, it's very difficult to retrain and start doing a completely new thing. But I guess we'll have to wait and see. The labor market keeps changing constantly. We cannot believe that the labor market is stable. Some jobs become less pertinent, others become more important. So I would look at it from the point of view of opportunities rather than threats. There are some threats, of course, which you have mentioned, but if you look at places like mines or any other plants that pose a significant hazard, or maybe there is pollution in terms of the environment, the working environment, that's going to be better. And that is where automated cars will be used first and foremost. Then we have the deficit of trained professional drivers at the moment. But we have to remember that these things are happening to some extent irrespective of what we want. During the pandemic, we have changed many things in supermarkets, for example, and more checkout points are automated or self-checkout points instead of having a shop assistant. So again, the employment levels are going down. There are fewer shop assistants employed. This is something that happens whether we like it or not, but we will have to give some thought to how to steer the labor market to avoid too high unemployment. At first, I think we'll have a bit of an intermediary state where certain stretches of roads or certain classes of roads will enable the drivers to use the autonomous mode. For example, when driving several hundred kilometers along a motorway, what is going to be happening elsewhere is when you exit the motorway. So the driver will be more of a manager of the lorry. So they will be driving in the autonomous mode along a highway or a motorway, but then when reaching the destination, the driver will drive the car. Right now, there's a shortfall of drivers, and in the future it might be solved by this, but full automation is still at least a dozen or so years ahead of us, and there'll be plenty of time to change your job. There are more and more questions from the participants. Let me ask this one. As I understand from the conference, the principles of testing autonomous vehicles on public roads will be changed. When can we expect for the final rules to be established and for the stretches of roads where these vehicles can be tested to be identified? And another question, do we have a place in Poland, a proving ground of assault, where you can test autonomous vehicles safely other than public roads? Let me start with the second question. We are using test tracks when we help the manufacturers test software. Now, we don't have a good test track in Poland. France, Germany, and Hungary, I think, have very good test tracks, and also Sweden. I know that the ITS is doing research and their tests on racetracks that they hire for the purpose, but I don't think we have a dedicated center. Although a center like that should be connected with a car manufacturer or a component manufacturer, because you require a lot of turnover for the investment in the test track to be paid back. And this is a question to the ministry. When will the legal side be regulated? The law on electric mobility mentions testing, but this mention is very general and people don't do the testing. Today we heard from the ministry representative that we still need a lot of time before we have a final decision on what criteria will have to be met in order to do the testing and what the schedule will be. Yes, we have hardly any information about the schedule. We also need to look at the Polish market. If it's an opportunity for us to use the domestic potential as far as the production of sensors and components of autonomous systems is concerned, then we should have an environment making it possible to test them. We are a powerhouse in terms of subcomponent production for at least key European car manufacturers. And now we are witnessing the transformation towards electric mobility. We have a number of companies that produce subcomponents for some of the leading brands, so we should have a site like that. But like you said before, we don't have a proper testing ground. A professional testing ground is what I have in mind. Is not just the roads used for testing themselves, but also mock-ups of buildings and other infrastructure, for example, to test the communication between vehicles. That requires a lot of capex, that requires a lot of maintenance money, and the question is whether there is enough demand for test tracks of that sort in order for them to be profitable. As for regulations, well, regulations are always half a step behind what technology has made possible. Step one was that those provisions in the electric mobility law, these regulations are imperfect because, for example, they don't provide for the introduction of new components to existing cars. They only talk about new cars. Now, we need to remember that we are a member of the European Union, so we are also obliged to use the harmonized law developed by the working groups in Brussels. For example, the WPR 29 group, which used to deal with drivability and braking systems, It has now been expanded in its remit to include automation elements, and that's where these regulations are developed and then implemented on the European level in individual countries.
And we do believe that this is exactly what ought to be expected. These works have been attended by representatives of the Ministry and the Institute for Motor Transportation, so we are aware of the pace of these changes. Nonetheless, we should definitely expect further iterations, and I strongly believe that as an automotive component manufacturing industry, not to mention the fact that we are also going to be representatives of automotive component manufacturers, so you definitely have something to say, and will have something to say in the future. We have another question from conference participants. Can interior monitor Can the car interior monitoring systems be also used to monitor the way and can also be used to monitor the way a disabled driver will be handling and using all the interior systems? Yes, that will be possible, provided that the camera watching the driver will capture the driver's entire attitude and posture, which means that the camera will have to be mounted in a proper location in order to allow for the driver's entire posture to be monitored. There are certain algorithms that would suggest how the driver is operating. For example, even the way that the driver uses his or her hands may suggest certain changes to behavior. So I think that the answer, this question ought to be answered in the affirmative. EMS, interior monitoring systems have been fitted with such solutions. My question is why? Why would that be required? That's a very good question. Well, indeed, it could assist the process of training drivers. We can also find that a driver was attempting to activate a certain system and failed. For example, the gel-covered or gel-coated steering wheel could have slipped, or his hands could have slipped on the gel-coated steering wheel. I think that could be a great source of information for instructors, for trainers. I think that visual or eyesight or eyeball movement monitoring can be a very valuable source of information, as is the case in airline training, for example, or in airline pilot training. The instructor can tell his student training to be a pilot that you were not looking where you should have been looking. My question arose from the fact that disabilities vary. Research has been launched in the Institute for Motor Transportation. The first stage is not necessarily the best one to pick specific solutions, technical solutions. So I don't think that this is a good question at this stage. Yes, we do agree that at later stages, such information could be valuable to the training process. All right, but for example, when certifying a driver, we might find, before certifying a driver, we might find whether he or she does not have any spastic cramp episodes that would be a counterindication to issuing a license. I am not sure whether I understood the gist of the question. That makes much more sense from the viewpoint of assessing adaptation systems in terms of their... overall use and purpose, well, possibly that should not be, such solutions should not be widespread or approved for daily use, but only for specific purposes. After a driver has been driving for a while, we could analyze certain behaviors. For example, once a driver covers 100 or 200 kilometers, it would be very difficult for us to assess how well the system was doing. I think that spot samples would be much more valuable. Nonetheless, yes, we could definitely use such solutions for specific purposes. But I have noticed another component that would be an obstacle to monitoring the entire cockpit. Let us consider the GDRP. I think that such processes may raise questions as to what should be recorded and why should it be recorded. Maybe the vehicle motion only should be recorded and nothing else. Okay, we have a little time left. We have one other question from the conference participant. The final question. Do we have anything we can automate in Poland, and do we have the measures to automate them? So do we have cars, trucks, passengers cars, or lorries that we could automate, and what kind of solutions we can apply to automate them? Doctor, would you care to begin? Well, that is really a very good question. We have... Well, Poland has companies such as ours. We are not a very large company, but yes, we do work on solutions for the automotive industry. We have clients from primarily from Western Europe, the US, and Asia. The question is quite difficult. It focuses on the Polish ecosystem. The huge intellectual potential is there. Our programmers are definitely no worse than those employed in the Silicon Valley. We have actually been observing a trend of people returning from the Silicon Valley to Poland, given the rising cost of life in the US, specifically in the Silicon Valley. So yes, we do have the talent. Nonetheless, what we are lacking is mature private equity, private capital, business angels that would allow us to effectively compete against foreign corporations. Well, we have already launched cooperation with international organizations. The software companies are there, the potential is there, the talent is there. I believe that manufacturing centers are quite typical for the automotive industry. We don't really have R&D centers, with the single exception of isolated cases in Krakow, Gdańsk, and Poznań, but they are usually foreign, funded by foreign manufacturing plants. There is one other component that we should talk about here. It would be quite difficult to respond to the question, how would or how do foreign nationals and foreign multinationals might respond. Nonetheless, since Poland is a country with a high share of used cars, of aftermarket cars, there is the need for retrofitting. For example, there are many companies offering solutions involving used cars to be fitted with autonomous driving parts. Maybe not at L5, but definitely L2 or L3 would be possible. That concludes the Q&A session. That also concludes our session. I would like to use this opportunity and thank conference participants for their attention. I would like to thank them for their questions, though these questions were definitely not easy. I would like to use this opportunity and thank our panel experts for responding. Thank you very much, and over to the studio. We just concluded a technical session moderated by Professor Andrzej Świderski of the Institute of Motor Transportation. We are going to take a brief break and then proceed with an international panel of experts who are going to be sharing their knowledge as part of our AV 2021 conference. So please
Welcome again after a short break. This is a conference AV Poland 2021. It's time for a session in English. Nowadays we live in very interesting times that allowed us to invite an expert from abroad also, who decided to share their knowledge about automated transport and autonomous vehicle. The title of this session is Knowledge as a Key to Conscious Trust. We'll be talking about the project from the program Horizon 2020, and this will be the session devoted to the topics of training and education of drivers, as well as issue of trust and acceptance to new autonomous technology. And now I would like you to invite for a little trip to United Kingdom, because there is our next expert. This is Professor Samantha Jameson from University of Leeds, and Professor will be talking about the issues that affect drivers' trust in automotion and about a methodology using objective and subjective measures. Welcome, Professor Samantha Jameson.
Oh, hi. Good afternoon, everyone. Yes, welcome to the UK. And first of all, may I apologise for the background behind me. I'm actually in work on campus today at the university, and I've had to find a quick alternative to my usual office. I'm actually sitting in the truck simulator today behind me. Apologies for the slight disarray behind me. So it's my pleasure to be talking to you today about driver trust in automation, and I'm just going to be going through my the experiment that we're carrying out at the moment using both objective and subjective measures of trust. Just a very quick overview of the Trustonomy project. We have 6 pillars in the Trustonomy project. You can see them there. On the left, HMI designs, a decision support framework, driving trainer curricula, which you'll be hearing more from one of the other project partners this afternoon, driver intervention and performance assessment, as well as driver state monitoring. And today I'm going to be talking to you about performance, trust, and acceptance. So why is trust important in an automated vehicle context? Firstly, low levels of trust by drivers may dissuade them from using it. However, high levels of trust may encourage abuse, so using the automation inappropriately. There are various layers of trust that we can start to explore in some experiments. And I've just, in the little red dash box there in the diagram, I've just outlined a few of those layers. The first one is dispositional trust, which is another word for personality, so how much an individual trusts or doesn't trust someone else or a product. Situational trust, which is what we measure when people are interacting with a product. Learned trust, your initial learned trust, so that may be what you think you might think about automation. And then dynamic learned trust. So as you become experienced with automation, how your trust starts to change. And our approach in Trustonomy, in this particular pillar, we've undertaken a large-scale online survey with a wide variety of potential users, different demographics, people who have different levels of technology use, and obviously being an online survey, we can distribute that to hundreds of participants. And these are our subjective measures of trust. So these are self-reported measures of trust. And the second part of our work in Trustonomy is a simulator study where we're going to be capturing behaviour and physiology for around 48 participants. And those will be our objective measures of trust, so how much people actually engage with automation. The online survey was distributed in 4 countries with 127 questions in that survey. And we gathered demographic information, so age, gender, license year, country of residence, obviously, experience of level 1 and level 2 automation, questionnaire about culture, trust scales, personality traits, and their attitudes towards technology in general, but also automation in particular. And we also took proxy measures of behavioural trust in 11 different road environments. Again, this is online, so not in real life environments. The aim of the survey is to build a model of how individual characteristics, perception of automated vehicles and technology in general influence trust. And that's a rather sort of complicated diagram on the right there, just lists all of those items that were used in the survey to try and predict actually what would drive people to trust in automated vehicles. And the preliminary survey results, I'm just going to take you through some of them today, just 3, because there's obviously, as you can see, there's many different aspects that we can analyse. But the first 3 that I'm going to talk through today are, did we observe differences in culture between the 4 countries in terms of trust in automation? Are participants in different countries more or less trusting in general than in other countries? And do the different countries report similar measures of behavioural trust in automated vehicles? So the first of those 3 questions, do we observe differences in culture between the 4 countries? And we think this is important to ascertain because this may be an important influencing factor in our model of trust. There are lots of different ways we can measure trust, and there's different communities will use different types of culture questionnaires, but we use a fairly popular one, a 32-item culture questionnaire, which allows participants in the survey to distinguish between 4 types of societies. And those societies are either individualistic, so personal goals take precedence over group goals, collective, vice versa, so group goals take precedence over personal goals, and the culture can either be vertical or horizontal. And a vertical culture demonstrates hierarchy with social rank being very important, whereas a horizontal culture is more egalitarian with members accepting equal status for all. And there, just in that little table there, I've given you some idea about what we found other people have found in the literature with regards culture and the 4 dimensions there that I've described. So Denmark, China, the US and India have very different cultures as measured by the culture questionnaire. So what did we find? Yes, we observed significant differences between our 4 countries of France, Italy, Poland and the UK. And we chose those countries because they are some of the partner countries in the Trustonomy project. Just to distill that rather complicated bar chart down, overall, we found that Italians reported higher horizontal collectivism compared to all other countries, and they're being more egalitarian and group goal oriented, whereas Polish reported higher vertical individualism than France and the UK, being more hierarchical and individual goal oriented. Just to clarify, this is a reflection of the respondents' own behaviours and not a value judgment of any society. So that's not to say that the whole of the individual Italian society is egalitarian and group goal oriented. That was just the results from the 200 participants in that country that we surveyed. The next question, are participants in different countries more or less trusting in general than others? We used a 21-item questionnaire by Evans and Ravel, which measures not only one's propensity to trust others, but also how trustworthy one thinks oneself is. So can other people trust me, for example? And again, we showed the results showed significant effects of those 4 countries, only on propensity to trust, not on propensity to be trustworthy. So the implications for both culture and trust is these seem to be important facets to include in our model of trust in automation, and we'll be including those when we build the whole model. Okay, I've just noticed this is an old version of the presentation, but I shall do my best to work my way through it. Okay, so the third question is what is it about those types of road scenes that you see on the right there that respondents may trust in with regards to using an AV? So we presented 11 different road scenes, and we varied those road scenes by road type. So there you can see urban, rural, highway. We also varied those road scenes by complexity, so whether it was a straight or a junction or a curve. And we also varied them by presence or absence of road users, so whether was other traffic present or absent. And we asked the participants to imagine themselves sitting in the driving seat of an automated vehicle with that automation on and in control. And we asked them to indicate on a scale of 0 to 10 how likely it would be that they would take their hands off the steering wheel, rest their feet away from the pedals, or take their eyes off the road. And this, we thought, was a good measure of behavioural trust in the automation. So our preliminary analysis indicated that across all of those levels of disengagement, so removal of hands, eyes and feet, that there were significant differences between males and females. So gender meant that males were more likely to disengage than females. With country also, we found that Italians were more likely to report that they would disengage than France, Poland and the UK, with the UK being least likely and France and Poland being around the same. And with regards to the other factors such as road type, complexity and road users, we found that drivers were less likely to disengage in urban areas where there were other road users around and where the road layout was complex as opposed to simple. So fairly sort of intuitive findings, which means that we can start to include these measures of behavioural trust again in our model. And the next steps, just to finish off with, will be our simulator study, and we're actually in the laboratory today piloting with our driving simulator, and we're going to be asking participants to drive through a number of roads with both expected and unexpected requests to intervene events. They'll be briefed with regards to the limit of the automated vehicle, and we'll have a look to see what situations they can and can't cope with. And those requests to intervene scenarios will be varied depending on how critical they are and how safety critical they are and how urgent they are. What will be novel in this simulator study, and I hope to be talking to some of you about this in the future, is we know that trust influences acceptance and use of automated vehicles, but the challenge for Trustonomy is to discover what affects state trust, so in the moment trust. So we're looking at ways of building trust, destroying trust, and then looking to see how we can build up trust again with various different types of scenarios. Thank you for listening. That's the end.
Thank you very much. It was Professor Samantha Jameson from University of Leeds with her presentation. Now it's time for our expert from Poland, Assistant Professor PhD Mikołaj Gruszewski, the head of Transport Telematics Center in Motor Transport Institute. And the title of the presentation is New Driver Training Challenges and Needs for Semi-Automated Vehicles.
Good afternoon. My name is Mikołaj Kruszewski. I'm a head of Transport Telematics Center in Motor Transport Institute. It's my pleasure today to show you our attempt to new driver training challenges and needs for semi-automated vehicles. In the beginning, I will try to in the beginning, I will try to briefly show the context and the problem that we are dealing with in driver training. And next, our project Transtonomy proposal as a solution for this problem. At first, it is worth to highlight that automation is not the only one trend in automotive sector these days. There are four so-called megatrends that are changing the face of transportation today. First one is car sharing, which is the trend to change an ownership of vehicles. Second one, electromobility, which is about changing power source, especially from combustion engines into electric ones. Third one is connectivity, which is the trend to share more data to improve traffic safety and traffic flow. And the last one is automation, which is the change to eliminate human factor from driving process. Some of these trends are standing in the opposition to automation these days, like in example electromobility. Automated driving systems needs a lot of energy to improve their computational performance, and it is still a valid problem for electric vehicles. So it might be a problem to get around with two or more megatrends together. Nevertheless, newest forecast from Victoria Transport Institute, Victoria Transport Policy Institute shows that in about 2045, we will be able to reach half of the new sold cars as a fully autonomous one. And in about 2060, we will reach half of the fleet as autonomous vehicles. So it will be a challenge for a few decades from now to deal with driver training for semi-automated vehicles. There are two main approaches to reach fully autonomous vehicles. First one, an incremental development, is represented mostly by traditional car manufacturers like Volvo, Tesla, BMW, Skoda, and so on. And it assumes systematic development of technology and going through all levels step by step up to the full autonomous vehicle. The second one, represented mostly by startups and big tech companies like Google and NVIDIA, assumes to reach fully autonomous vehicles without indirect levels. In the context of today's topic, all these indirect levels are really important, while they assume that the driver is still needed in a car. From SAE level 1 up to level 4, the driver is essential, and so it is the communication between him and the vehicle. Various systems needs different skills, and for each of them, knowledge about its usage, capabilities, and limitations is necessary. When focusing on fully autonomous vehicles, we are not really focusing on perfecting their technical aspects, but when focusing on human-centered autonomy, we need to focus more on the driver, so to perfect driver monitoring, communication with him, collaboration with him, and also give a future of personalizing these operations. This is what we find nowadays as a big and under-evaluated challenge. Users typically do not know how exactly to use their automation features in their vehicles. Practically no one will read 900 pages of vehicle manual for each vehicle he has. It is a contemporary consent for now, and it's not working well these days. So in the future, when more more systems will be available, that will not work at all. Sorry. Current driver training related regulations do not provide new drivers with necessary practical skills and knowledge of the recently introduced systems. And what more, users are very often confused about the system functions and limitations, while they vary depends on the manufacturers. It all brings us to the conclusion that technological changes and education should go in parallel. This is what we have defined as our goal in Trustonomy project funded in Horizon 2020, where 16 members from 8 European countries takes part. Driver training is one of the so-called pillars of the project, where most of them are strongly related with the driver. Driver training in the project will be intensively tested in 4 different contexts. We will use different platforms, different research groups, different road conditions, different road requests to intervene situations, and also different system limitations while testing them. Our pilots will vary between level 1 to level 4 SAE systems, tested on a group of at least 400 participants and covering both theoretical and practical training. For the purpose of the theoretical training, the special e-learning online platform was developed. We called it CMU Learning Platform. After this training, the trainee will know exactly what he needs about the context of autonomous mobility, benefits and limitations of the system, and legal and liability context in this topic. Our training consists of 4 modules. First one is introduction, next semi-automatic simulation training, and summary up to the quiz, which is an evaluation component. Of course, the most important one is the semi-automatic simulation training, which is a video-based interactive solution to train the driver with necessary skills and acquire or improve his knowledge about the systems. The training itself lasts only about few minutes, like 5 or 7 minutes, and consists of system activation and deactivation, setting system parameters, and in example for our highway chauffeur L4 system, such specific operations like how to react on request to intervene, how to change the lane on demand in the system, and what happens when minimal risk maneuver is launched. Now, and I mean even today, we are testing this course in our premises in Motor Transport Institute using high-class driving simulator. For the purpose of the project, we are going to test to compare it with traditional practical training and short manual reading. After assessment, we will improve our platform and develop the version for 3 different types of end users that will be tested in second round of pilots. And next, after gathering feedbacks from second round of pilots, we'll improve the system once again and prepare it for broader implementation. If this approach seems interesting for you, please don't hesitate to visit our project website and to follow us on other media to be up to date with our project results and solutions. Thank you very much for your kind attention.
Thank you very much, Assistant Professor PhD Mikołaj Kruszewski from Motor Transport Institute. As I said before, this edition of AV Poland 2021 is an international conference. That's why Another expert is from abroad. Welcome, José Solas, Head of Innovation, Automotive and Mass Transport Instituto de Biomecánica. And José Solas will be talking about supportive acceptance of autonomous vehicles, coloring automated driving with human emotions. Welcome.
Hello, good afternoon. Thank you for inviting me to this session. I'd like to talk this time about the SUAVE project. SUAVE project is focused on the challenges of the level 4, level 5 vehicles and the acceptance of this kind of vehicles. Before the project, we know that one of the main causes of the lack of acceptance is to make development ignoring which are the needs and requirements of the future users. So in the case of the connected automatic vehicles, there is an important degree of acceptism based on the awareness of the complexity of the technology. So things that are very common or usual for a technician like we are not as common for the general public. So the main idea of a SUAVE project is to fill the gap between this new concept of vehicles and the knowledge and the level of acceptance of general public. To do that, we have created a project in which we focus on 4 main aspects. One of them is the social and psychological research about acceptability. Then to create a cross-cultural framework about ethical and legal issues. Third, to create a sort of layer that permits us to humanize the vehicle. We call it Alfred, that is formed by several layers of information. And finally, to develop during the project a platform, an immersive platform to check all these hypotheses of vehicle acceptance. I've talked about before about Alfred. So Alfred maybe is the key of this project. It's a sort of layer that will combine with the vehicle dynamics that help us to make that this autonomous vehicle behaves in a more human-like manner. So Alfred is an architecture that is based in 2 main blocks. So one is EMI, that contains the ethical module and the empathic module in some manner considering which are the needs, which are the requirements, which are the intimate requirements of the occupants of the autonomous vehicles in the future, and then AC, that's an interface that, taking that into account, modifies the dynamic of the vehicle, the interior characteristics, or gives information to the occupants in order to enhance the acceptability of being driving by autonomous vehicle. So the main objective of SUAVE is to consider the human in the center. So we employ a human driving design approach where the user has been considered from the very beginning with questionnaires, with a participatory process consisting on surveys in 6 European countries with the participation of about 3.9 kilo citizens and at least 100 different panelists. So we consider an iterative process which involved 600 participants in each user test in 5 European countries. So we gather information from a societal point of view, from a human factors perspective, and also carrying out human factor testing. The first part, the psychological research of the acceptability, is a study of the acceptability of the vehicle that has been taken in different countries, a large-scale survey, that gives us information about the attributes and the perceived characteristics of this new vehicle. So these are the factors that are key to understand how the autonomous vehicle is perceived and what are the needs that people have about this kind of vehicle. Second, for us, very important, as Foreign mentioned in one of the conference before this one, that there's clear differences due to cultural background between different countries. So one of the main goals is to take into account those divergences observed between countries, and also the difference between the perspective of the users and the perspective of the experts. That's really quite different. So to organize, identify, and prioritize the needs, especially the ethical issues, is one of the keys for the acceptance of this kind of behavior. Finally, we need to gather all this information in the shape of something that can be really put on an autonomous vehicle. To do that, we have developed an emotional model to understand the emotional state of the passengers in real time. That means we want to know during a real driving task, using different kinds of sensors like cameras or sensors embedded on the seat or around the driver or the passengers, which are the emotional states of the driver. We measure heart rate, breathing rate, eye movements, head movements, and with all this information, we are able to extract the emotional state of the driver or emotional state of the passenger and obtain two parameters. The arousal, that's the level of exciting, the level of or the calmness of the passenger, and the balance. That means that if this arousal is positive or negative. With this information, we've been able to create this emotional model of the map that you see on the image on the right, that can give us an estimate of which is the emotional state in the short term and the long term of the passengers. All this emotional model has been created with experimentation in a driving simulator we'll see later. This cognitive model and emotional model help us to determine which is the mental state of the driver, which is the risk perception, and help us to represent the situational awareness. So we are able to understand how the driver is understanding what's happening around him or around her in this autonomous vehicle scenario. So Alfred, in some manner, gathers the information regarding the driver and the passenger of the vehicle, transform that information into an emotional state, and then gives an answer, changing the dynamics of the vehicle, or giving proper information to the driver. So we have developed a functional smart cognitive assistant to provide the passenger the information about the traffic situation, vehicle behavior, in the way that it adapts to the passenger state. So it's fundamental that the driver and passengers have information, but not too much information about what's happening. They can be overwhelmed, or not a short or a lack of information that make them feel disoriented in some cases. So as I was mentioning before, we've been working with different dynamic modes. So we simulate 3 kind of different training modes. That's the urgent modes, the race mode, and a comfort mode. And we check which is the response of the occupants using a driving simulator, the IFHCD driving simulator platform, to check which is the response in front of different scenarios. So we have defined a total of 36 scenarios simulated in our car driving simulator. And the idea is, as I mentioned before, to understand this immersive situation, how is the acceptability and acceptation of this autonomous system during different groups. So by now, we have an initial version of this emotional model that is able to obtain a short-term related emotional state based in the last 10-20 seconds. And our ambition is to create a sort of long-term determination of the arousal and the level of emotion of the passengers in order to provide a forecast of the future emotions. So now we are validating the hypothesis with different developments, and the idea is to make a second loop with more than 300 subjects at different European countries. So the main idea of SUAVE project is to enhance the acceptance of the vehicles, making the industry to really understand, not only from a mechanical, but from an engineering point of view, how this autonomous vehicle has to behave, but which are the rules that will make that passengers and drivers feel comfortable, feel safe, and trust, as some of my colleagues said before, and really trust in the response of the autonomous vehicle. So the human driving design, that means to not only asking to the people, but also making them participating in all the testing to speed up and reduce the cost of the test. So the idea of SUAVE is to contribute to generate also new business models, because during this process, different kinds of personal data will be gathered. It's very important, and the user will be the owner of this information, and he or she has to decide how to exploit it. Besides, new technologies will appear during the project, like new system of non-invasive sensors, new processors, or new algorithms to determine which is the real state of the driver of the passenger. So finally, I would like to thank all the partners of the project, which have been participating in them. So we hope to have new results in the following months with participation among users and a much more complete alpha model. Thank you.
Jose Solas, Head of Innovation Automotive and Mass Transport Institute de Biomecanica. Thank you very much. Now it's time for another trip at AV Poland 2021 conference. We're going to Italy because there is our next expert. Please welcome Manuel Picardi, PhD, General Secretary, European Driving Schools Association, and his presentation about simulators in drivers training.
Good afternoon, everybody. Thank you very much for the invitation. I'm very glad to take part of this interesting meeting today. And I hope to give you some interesting information about the project we already completed. It's called SimuSafe. So the project concerning about the use of simulators into the driving training and the ADI, so the Authorized Driving Instructors curricula. Just a few words about the EFA activities. So we currently represent 23 National Driving School Association. We already have 11 affiliate members that are not European driving school associations, and 7 road safety partners are the different road safety stakeholders involved into the training process. Which are the aims of the European Federation is try to standardize the education and the examination for future drivers, standardize the education and examination for the driving instructors, and find a minimum standard for driving schools. We have created since a couple of years an EFA driver training lab. So is an academy just to develop new devices, new training tools useful for the driving instructors. And as you can see, we are now developing new models for tracking the training process, and we are thinking about tracking the driving exams as well. What about the SimuSafe project? The SimuSafe project is designed to create a new kind of simulators, because currently the simulator has a limited use in safety studies due to the limited realism of road users' behaviors in models. SimuSafe will bridge the gap by collecting and interacting sources of road users' behavior to build more realistic simulation environments. is data collecting from simulation will be correlated with naturalistic driving tests, such that the simulation and model aspects are the closest possible to real-world data, which were the aim of our association, which is the contribute of our association. Definitely we have to deliver 3 tasks. The first one is collecting information of EU training curricula, both for driving instructors and for novice drivers, so for students for Category B license, organize international workshops and seminars, and definitely the last but not least, create new training modules. So starting for the first pillar of our activities was a very huge work to collect information through the different countries. As you can easily see into the slide, the current scenario of driving school, of the driving training is really fragmented. It's really fragmented. We analyzed the data from 21 countries, and I just take some questions, so just for show you how it's complicated to analyze the data and to provide an harmonization system valid for everyone. So starting from the first question I selected for you, so mandatory attendance in ferry course is completely different country by country. Is the practical training before ferry test completely different from one head, the other one no head, or the hours is completely different. Examination body, if there is the public sector or the private bodies for examination, completely different. Compulsory training, the practical lessons, completely different. The use of simulator currently is not so popular. And just one country is compulsory, is Czech Republic. And the ADSA perception test is not at all popular. The second phase license, so we call it gradual driving license, is not also popular. Minimum learning period before the test is completely different country by country, and accompanied learner drivers change country by country. And regarding the second part of the first pillar, so collected information on the driving instructor's curriculum, as mentioned before, is quite similar, the scenario, because it's completely fragmented country by country. And if you just take your attention on the 6 questions I selected for you, is the difference in teaching qualification in all categories of driving license is completely different. The requirement for access to the profession, such as driving license and year of experience, is completely different country by country. The use of driving simulator is not popular at all. The periodic training system is not popular. The use of simulator in initial and periodical training is not in use, also because in most of the countries does not exist actually the periodical training for the driving instructors, and the need to update courses for driving instructors everywhere is well received. So everywhere is understood that we need this kind of further training. The second pillar that, of the activities that IFA organized was to organize international workshop and seminars. The biggest one we created, it was in May 2019 in Brussels, and we invited DG Move delegates and the different stakeholders as DICRA, European Transport Safety Councils, and all the stakeholders that we talked we can give a contribute to the well develop of the event. And which are the conclusion of this first international seminar? Definitely the main issue currently remains that a joint regulation as a measures and guidelines are necessary to make sure that autonomous vehicles are safe rather than comfortable and convenient for the user. The use of driving simulator would provide the possibility to expose drivers to situations they cannot encounter during a regular training, and in addition may make drivers aware of dangerous situations they can be involved with. Definitely we will see in deep later this part. The main event organized by EFA, it has been in Turin at in mid October of 2019. We joined a lot of stakeholders involved in the driving training curricula, driving training web server providers, and different stakeholders involved into the training process. And we have 150 attendees during the event, and the title of the event was technology is a threat or an opportunity. So how we can manage the technologies, devices and tools for get better driver training. And the main conclusions are the need to understand how to use the modern and effective technologies and tools. Our drivers training should be supported by technologies, both novice drivers and driving instructors, and how to create a scheme for lifelong driver training. During our 3 years of project, we also disseminated a lot of, during a lot of Congress, the SimoSafe activities that we rolled out. And for instance, in the first left top slide pictures, as you can see the presentation into KSA Congress, or on the right top presentation of the project to UNEC, and then the production of some devices, these alcohol devices. So one of the things that's probably I hope we'll be able to show you later is the production of the video as a EFA manifesto, just to show which are the current needs of driving school and which is the way that we have to follow to increase our skills competence linked to the ADAS and autonomous vehicles. So what we have created, the last and probably the most important pillars of our activities is the creation of new training module for novice drivers. We created an IFE training matrix because for a new system of driver training. We separate the skills from the knowledge. We think that all the topics that regarding the road safety, they need to be certified into the driving school and not need to be evaluated by an exam. Because as we already repeat, most of the people that go to the driving school go there just for getting the license, so just for passing an exam. They are focused on this, and they are missing the real concept of road safety. Otherwise, we have the topics on knowledge, as the road signs and all the other rules that it will be necessary that the drivers, the attendees, they will be able to manage this, have to be evaluated by an exam. So we think that currently with the new technologies, the training technologies, information, all the things is not very complicated to manage this kind of certification for the driving training. And regarding the simulators, so the driving school, they accept with pleasure the introduction of simulators in the situation, as mentioned before, that's really complicated to produce during the regular training system. So we are speaking about the bad weather condition, so the right use of the ADAS, driving by night, eco driving, or, for instance, the certification of the right use of the manual transmission. Currently, one of the biggest problems we are in face as a driving school sector is that we can't buy and use the electrical vehicles or the hybrid vehicles, because if we use this for the training and then for the exams, our students, they will have the restrictions on driving just cars with automatic transmissions. And so we say that maybe it could be an option that introduce the simulators to make some certified training with the manual gearbox and don't have the limitation, the restrictions of code 78. The biggest difficulties that we have on the introduction of the simulator is that generally speaking, in Europe, the driving schools are family business, and so it means that there is no room and no staff available for simulators. So it will be required to increase the spaces, increase the costs, and also the employees to teach to the students how to use properly the simulators. And the economic crisis does not allow a big investment for most of the driving schools across Europe. For the driving instructors curriculum, we created a new model, and is a revolutionary model because we introduced the concept of road safety expert. A road safety expert is a person involved into the training process and could be the driving instructor or the driving examinator. So following the model of university, so with the different modules, we say that the 75% of the program to become a driving instructor or become a driving examiner will be the same. And the remaining 25% will be dedicated especially to become a driving instructor or to become a driving examiner. This is very important because for the first time in our life, we will have the two subjects, they will speak only one language. And so they understand, they have the same concept of rules and road safety as well. And regarding the use of simulators, as similar than before, we say that we are absolutely in favor to the introduction of the use of the simulator into the hazard perception topic in bad weather condition, right use of the ADAS, and eco driving. And the current problem is that does not exist one European directive concerning the minimum standard for training the driving instructors. And so now we hope that with the end of the year, it would be possible from DG MOVE to apply modification of the current directive, and definitely there will be room enough for introducing the concept expressed into the SimuSafe project. So I hope to be clear. I completed my presentation, and I would like to show you the video prepared during the SimuSafe project, as mentioned before, that described the role of the driving school into the civil society and what we want to, how we want to embrace the new technology. Thank you very much for your attention.
Thank you for this presentation. Last but absolutely not least, Ingrid Cosmo, PhD Senior Research Leader from VTI. It's our next expert with the presentation about Project Brave, Brighting Gasps for the Adoption of Automated Vehicles. Welcome.
It's an honor to have been invited to this event and to also hear all the presentations before. I will, as was said, present the BRAVE project, Bridging Gaps for the Adoption of Automated Vehicles. You may ask, who is BRAVE? Well, this was who we were, and when I say was, it is because the project has in fact ended. We ended it in February this year. It went on for 45 months. It involved 10 partners from 7 countries, whereof 2 were actually outside Europe. Yes, this was the project. And we have within the BRAVE project, we wanted to find out what influences road users' adoption of highly automated vehicles. How can that be increased? And what are the gaps for acceptability of highly automated vehicles? So this is sort of level 3. We have discussed level 4 earlier this afternoon, but this is level 3 on the SAE scale. And also give examples of solutions that could bridge those gaps. Also, it's interesting to do research, it's interesting to develop concepts, but it's also very important that they are spread and actually penetrate the market. So that was also one of the questions. How can we reach a wider application? So therefore, you can in short say that we aimed at identifying gaps regarding acceptance, to address those by developments and demonstrations, and then also to have activities that encourage the bridging of the gaps. So our objectives, which actually correspond to the actions that we took, were that we wanted to make a multidisciplinary study to look at requirements and expectations, and not only of drivers, because we think that it is equally important to have the entire road user community on board when we speak about acceptance. So we wanted to look at all road user types and also look at those who are a little bit more organized stakeholders. There was somebody earlier this afternoon saying that there was a difference between public and experts. We wanted to look at HMI and to see how we could address findings for and by HMI, and also to look at automated driving assistance systems, and see if we could enhance them by having predictive algorithms. That is some way of predicting actions of other vehicles and other road users, so that we could have a shorter reaction time of the vehicle in emergency maneuvers. And then our idea of how to bring this all to the market and into realization in vehicles was to do that by looking into protocols of regulation and consumer testing, Euro NCAP, and propose how systems like this could be evaluated and how you could get credit for those and sort of contribute to the Euro NCAP stars, for example. We did not work in isolation. There were some sister projects involved as well, and we worked with Interact, Trust Vehicle, and also ARDAS and me to some extent. We did, as I said, do a population survey, and or we did a multidisciplinary study, and one way we addressed that was through a population survey. We did that online, and we for each of the 7 brave countries we received about 1,000 respondents, and we wanted responses both in the respondents should be both in the role of vulnerable road users, and also in the role of drivers of conventional cars, in addition to drivers, because there is so much focus on drivers, but we said it is very important to have the other road users involved as well. And what we found in this study was that in general there was quite positive acceptance among the respondents, that they were kind of positive to level 3 cars. However, they didn't really trust the vehicles, and they were also skeptic about using automated vehicles themselves. So, as was pointed out before, trust is sort of it is an issue that needs to be addressed, and they would like to have some kind of communication, recognition of that they are recognized by the automated vehicle through in a way that you can understand that outside the vehicle. So some kind of external HMI. There were differences between different road user groups and also between the countries of residence. And there are deliverables that address this that are, and also research papers that are publicly available if you would like to find out more. I said that we would also look into HMIs, and here we took the results from the survey, and also, of course, studied what has been done outside the project to develop HMI guidelines for the interior HMI. And as was pointed out also earlier today, that it is important with how you communicate with the driver and what the HMI does. And if the system is in control, the driver does not want to be disturbed. So then you shouldn't sort of just inform for the sake of it. It is important to understand what the vehicle does and why, because that can really enhance the trust. And the driver's level of trust and experience is important to capture. So I think it was interesting to see what is done in the SUAVE project to capture the emotional state, for example, so that the amount of information and the timing of information is adjusted to that trust and experience with the system. And then mainly use visual feedback was what we found would be important. And if that doesn't work, only then you should have audible signals or haptic feedback. And I should say this was developed through focus groups, co-creation studies of different concepts, and then simulator studies. So we did develop general guidelines for HMI HMI design, and we also worked out a driver monitoring and warning strategy, where what types of alarms should be applied when and to what type of driver. So I think this we did not have a automaker among our partners, and we really aimed more for general guidelines that can be applied by anybody who wants to design or improve a vehicle interior. Then we also looked at external HMIs, and here we used virtual reality pedestrian simulator. So it was really the pedestrian that was in the focus. We took the population survey, we looked at the state of the art, and we had user workshops and developed also here general recommendations. What we did study, for example, with the virtual reality simulator was a vehicle with a very rudimentary but nevertheless easy to understand external HMI. And then the vehicle that approached the pedestrian would also brake or not brake, but not only using the sort of sign, the visual sign of an external HMI, but also having the vehicle dynamics as one factor of indicating what the vehicle is up to. So the general recommendations include that you should not give guidance, sort of tell the pedestrian that please cross now, but should rather indicate the vehicle status. And also the automation status was preferred by the test subjects. And if you need to warn, do that by sound and use familiar sounds, nothing special or fancy. And then, as I said, it was very important with the vehicle movement. If the vehicle brakes, how that is done, it should be synchronized with the external HMI so that you get a much better understanding of what the car is up to if you have the braking and the external HMI carefully integrated in their timing. Then we developed, as I said, prediction algorithms where we did develop both a predictive model for detecting and understanding if persons standing at the roadside were pedestrians that wanted to cross or not, if they intended to cross, and that then the vehicle would brake and also send out an external HMI signal. We also had a predictive system of surrounding vehicles that were cutting in front of the ego vehicle. To do this, we had to create a data set, which is available for its open access. It's called Prevention Dataset, and it includes lots of data on vehicles and VRUs that can be used for those who want to develop prediction systems. So here the vehicle indicates that it has seen VRUs, pedestrians in this case, and it uses eye contact but also posture of the pedestrian to understand if the pedestrian is going to cross or not, and then the vehicle can adjust its actions accordingly. The same or similar, there is a predictive system for lane change prediction that looks ahead of the vehicle and predicts if there is going to be a lane change, and then it adjusts, it automatically adjusts its behavior to this fact that there is a vehicle cutting in. We have assessed how good these predictive performances are, and they are accurate to 85% of predicting actions for both pedestrian and cut in, and while a human takes about 1.08 seconds to detect this and act, the Brave delay is much lower, so it's about 2/3 of that, so it significantly decreases the reaction time of the vehicle, which we believe is trust enhancing. So it would, what is this good for? Well, we think this would then be good to drive driver trust in automated vehicle, and also to make it possible to react to sudden pedestrians, and also support the driver to engage in other tasks to take advantage of the automation. And what this does additionally actually is that it creates a smoother deceleration of the ego vehicle, so the safety and comfort gets higher, which also contributes to the acceptance, rather than if you have constant, very abrupt braking and acceleration. And then, as I said, the idea was that we have the guidelines and we have the prediction systems, and how do you get these into the market? So we said we have to have a way to evaluate these systems, and therefore we looked through what Euro NCAP has as their test protocols, and we developed 4 recommendations on how to take advantage and assess prediction systems. So there is one recommendation is to use an articulated pedestrian dummy so that you can predict the intention, and then a couple of scenarios here where we today don't have any assessment of automated vehicles. We also suggest the last thing I said on the previous slide, that smooth driving could also be assessed, and we have proposed the criteria for that as well. So this has been a discussion with Euro NCAP, and that is ongoing, and also with the regulatory bodies on how you can assess the benefits of predictive systems. So to conclude this presentation, we found that acceptance, as I said, is positive. It's not widespread. There is a lack of trust, and that it is important to be transparent. And we developed the anterior HMI guidelines and a concept, and also driving, monitoring and warning strategy, together with this predicting and anticipating system, so that as means to address the trust. And then the next step is to continue the discussion. Also now, once the project has ended, we are still continuing our dialogue with the working groups of regulatory bodies and consumer testing to see if they could take on board any of these findings. And there is a website where you can access our deliverables and other information, some videos and other information from the project. And I hope you visit it, and that we're looking forward to seeing you accessing it. And thank you very much.
Thank you, Ingrid Skosmo, PhD Senior Research Leader from VTI. And thank you for being during our English session. Knowledge is a key to conscious trust. And of course, a great thanks to our experts that decided to share their knowledge during AV Poland 2021. A to była nasza ostatnia prezentacja.
This was our last presentation as part of AV Poland 2021 conference. I hope that you have gained new knowledge from our fantastic experts, and this conference wouldn't be possible without our partners and friends. We had the honorary patronage of Andrzej Adamczyk, the Minister of Infrastructure, and the Infrastructure Committee of the Polish Parliament. The transport faculty at Warsaw University of Technology was our partner, as was the Polish Academy of Sciences. The Polish Research Center and Robotic AI were our further partners, as was TVP Info, the Polish television channel. Now, during our AV Poland 2021 conference, we have inaugurated the Competence Center for autonomous and connected vehicles at the ITS, and this task force will continue work on the future developments and appearance of autonomous vehicles on Polish roads. Information about that can be found on the ITS website. The ITS social media is the place where you can find the whole conference. It will be posted there. You can either view all of it again, or you can select individual moments you'd like to come back to. Thank you very much for joining us for AV Poland 2021.